There is a moment, usually late at night, when the sky above you does something strange. The clouds have cleared, the city has gone quiet. You tilt your head back and for a breath or two the universe presses down on you from every direction at once. It is enormous. It is populated. Stars cluster and scatter in every direction you look, and the longer you look, the more of them appear, as if light itself is multiplying behind your eyes. You feel in that moment, surrounded by something immense and alive. You feel as if the universe is full. That feeling is the beginning of a deception, not a cruel one, not a conspiracy of physics or a failure of perception, simply the oldest illusion in human experience, that what we can see represents what is there, that what shines is what matters, that the universe has organized itself around brilliance and density and motion, and that all of it is, in some meaningful sense, close. What you are watching from the surface of this small planet is a performance staged across hundreds of billions of light years, and the stage itself is almost entirely bare. This is a journey beyond the universe as we think we know it, into the spaces and silences that define what existence actually looks like at the scale where human instinct stops working entirely. And if you want to keep following the questions that hide behind the light, subscribe to Beyond the Universe, because this journey is not about finding comfort in the cosmos. It is about looking directly at what the universe becomes when the familiar picture begins to disappear. Begin then with what you believe you are seeing when you look up. The night sky presents a canvas that appears generously filled. The naked eye, under ideal conditions, can resolve perhaps 5,000 individual stars in both hemispheres combined. A modest telescope reveals thousands more. A serious observatory instrument makes the number stagger upward into the millions in a single field of view. The Milky Way itself, our home galaxy, contains somewhere between 100 billion and 400 billion stars. When you allow that number to rest in your mind without calculating it away, without abstracting it into manageable academic distance, it is an almost incomprehensible quantity of burning, radiating, nuclear active objects. The sun, which alone heats a planet and drives its weather and biological cycles, is one of perhaps 300 billion similar objects in this galaxy. The galaxy is one of an estimated 2 trillion observable galaxies in the universe we can currently reach with instruments. 2 trillion, each containing hundreds of billions of stars. So when the feeling arrives, standing beneath a clear sky, that the universe is full, it is not wrong exactly. It is merely misled by the mind's inability to hold scale and distance simultaneously. The stars you see are there, the galaxies are real, the light is genuine. But the conclusion your nervous system draws from that data, that the universe is densely populated, that it is a place of concentrated presence, that matter and energy dominate the landscape of reality, is not supportable. It is, in the most literal sense, the opposite of what cosmology reveals when it turns its instruments outward with sufficient patience and resolution. Consider what it means for a galaxy to exist within the universe. The Milky Way is a disk of gas, dust, and stars roughly 100,000 light-years across. It is physically immense by any human scale. It takes light, traveling at approximately 300,000 kilometers per second, 100,000 years to cross it from edge to edge. And yet the nearest large neighboring galaxy, Andromeda, sits approximately 2.5 million light-years away. 25 times the diameter of our own galaxy separates us from the next significant structure of comparable scale. Between these two systems, almost nothing exists. A scattering of smaller dwarf galaxies, thin clouds of gas too faint to see with any but the most sensitive instruments, and then distance. Enormous, characterless, completely uninterrupted distance. That gap is not an exception, it is the rule. The universe does not arrange its galaxies like stars arranged in a galaxy. Densely packed and gravitationally intimate, galaxies are distributed across space with separations that make them, by any meaningful measure, absurdly isolated from one another. The ratio of the size of a galaxy to the space between galaxies is comparable, very roughly, to the ratio of a single grain of sand to several miles of open beach. Not the beach, the space between the grains. When you look at an image of deep space and see galaxies scattered like luminous flecks across a dark field, your brain groups them together because they are the only things visible. It interprets the image as a populated field, but the image cannot show you scale. It cannot show you the reality that those flecks are separated by distances so vast that even the fastest thing in the known universe would travel for millions of years between them. This is where the comfortable version of the cosmos begins to come apart, because once you accept that galaxies are islands of matter, in an ocean of mostly nothing, you are forced to ask what that ocean actually is. What is the space between galaxies? What fills it? What does it mean for a volume of space to be almost entirely empty of matter, and yet to be real, to occupy a region of the universe, to have properties, even if those properties are defined almost entirely by absence? The instinctive answer is that empty space is nothing, not a thing, not a substance, just the absence of something else, the way silence is the absence of sound. But physics abandoned that intuition over a century ago. Space is not nothing. It is a medium with geometry, with curvature, with measurable properties, with the capacity to expand. The vacuum of deep space is not the same as non-existence. It is a state of the universe with its own physics, its own energy content, its own future behavior. And that distinction between empty as absence and empty as a physical state turns out to matter enormously. It turns out to be one of the most consequential facts in all of cosmology. But before arriving at that consequence, it is worth pausing on the sheer scale of the emptiness itself, because numbers, even staggering ones, tend to slide off the mind. What helps, sometimes, is to try imagining a descent, not a comfortable one. Imagine yourself above the local group of galaxies, the cluster of roughly 50 to 80 galaxies, including the Milky Way and Andromeda, that are gravitationally bound to one another. From this altitude, they look compact, even intimate, a small family of luminous objects. Now imagine pulling back. The local group shrinks. Around it, other groups appear. The Virgo cluster, containing thousands of galaxies bound together under enormous gravitational attraction. The Fornax cluster, the Centaurus cluster. These groups and clusters themselves belong to a larger structure, the Laniakea supercluster, a gravitationally influenced region containing the mass equivalent of roughly 100 million billion suns. It stretches across 500 million light-years. These numbers accumulate very quickly toward incomprehensibility, and that is, in a way, the point. But what happens as you continue pulling back, as the scale grows beyond superclusters, is stranger than the structures themselves. The structures begin to disappear, not because they get too small to see, but because the universe at sufficiently large scales begins to look less like a crowded gallery and more like an almost empty room with thin webs of material draped across the corners. The clusters and superclusters reveal themselves as not representative of the whole. They are concentrations, overdensities, regions where matter bunched up over billions of years of gravitational assembly. And between them, separating them, dwarfing them in raw volume, are the places where matter chose not to go. Cosmologists call these regions voids. The word is accurate in its directness. These are not merely gaps between objects, the way a gap between two books on a shelf is still part of the shelf space. Voids are coherent, measurable, enormous regions of the universe where galaxy density drops to near zero. They are not framed by anything close enough to be relevant. They are simply the universe with almost nothing in it, and they can span hundreds of millions of light-years in their longest dimensions. The largest known cosmic voids have been measured at over 1 billion light-years across. To place that in some perspective, if you were to enter one of these voids traveling at the speed of light and travel to its approximate center, you would have passed through 500 million light-years of essentially nothing. No galaxies, no clusters, no sounds, no heat, no radiation above a near absolute zero background hum, no direction that leads more quickly to something than any other direction. Just the geometry of space, expanding quietly around you, while the thin shell of the universe's visible architecture recedes behind you. Most of the universe is that, not the galaxies, not the superclusters, not the filaments of gas and matter that cosmologists have mapped with increasing precision. The voids. By volume, the voids account for the dominant fraction of the universe's spatial extent. They are not the spaces between the universe's contents. They are what the universe mostly is, and everything else, every galaxy, every star, every planet, every particle of dust you have ever seen or touched or built a civilization upon, is crowded into the thin boundaries where voids happen to meet one another. Consider what that means for any instinctive picture of the cosmos as a place of abundance. The human eye, scanning a deep field image of thousands of galaxies in a patch of sky no larger than a grain of sand held at arm's length, naturally interprets abundance. The universe looks occupied, but those thousands of galaxies exist in a two-dimensional projection of a three-dimensional space. They are stacked in depth. They are separated by millions and billions of light-years. The image compresses all that distance into a flat surface, and the mind reads density where the reality is almost complete isolation. This is not a trivial optical trick. It is the central perceptual deception that shapes almost every intuition a human being brings to the cosmos. We evolved on the surface of a planet. Our perception of density, Distance and populated space was calibrated over millions of years of navigating an environment where something visible was, by definition, reachable, where something close enough to see in detail was close enough to matter, where fullness was a guarantee of relevance. None of that evolutionary calibration applies beyond the atmosphere. The distances involved in even the nearest cosmic interactions are so far beyond biological intuition that the mind cannot feel them. It can only count them, and counting is not the same as understanding. There is a particular quality to the emptiness of intergalactic space that resists easy description. It is not the darkness of a room with its lights off. It is not the quiet of a forest at night. There is no analogy in human experience that genuinely captures it, because human experience is entirely embedded in a world where matter is the default condition. Even in the driest desert, even in the deepest trench of the ocean, even in the thin upper reaches of the stratosphere, the substance of the world is there. Molecules, particles, radiation, the structural fabric of a planet that assembled itself from solid and liquid and gas. Strip all of that away and continue stripping until you have traveled 100 million light years from the nearest galaxy, and what remains is a state of reality for which language, developed by creatures who have never experienced it, simply runs short. And yet it is not random. That is the first intimation of something deeper. The emptiness is not evenly distributed. The voids are not merely the spaces that happen to be left over when matter clumps together by chance. The voids have shapes. They have boundaries. They connect to one another through a network of even larger structural patterns that, when mapped on the grandest scales, reveal the universe to have an architecture. Not an architecture of presence, not buildings and streets and filled rooms, but an architecture of contrast, an interlocking pattern of dense filaments and empty volumes that repeats across distances that beggar every human unit of measurement. Cosmologists call this large-scale architecture the cosmic web. The name carries its own accuracy. Think of the web not as something that catches prey, but as a three-dimensional lattice of filaments, long strands of gas and dark matter, along which galaxies cluster like moisture beads along a thread. Where several filaments intersect, enormous galaxy clusters form, the densest nodes in the structure. And between all of these threads and nodes, bounded on all sides by the approaching filaments but never touched by them, the voids persist. They are the cells of the web's interior. They are the negative space that makes the positive space legible. When this structure was first being mapped, astronomers described it in terms that carried an almost involuntary sense of recognition. It resembles, in photographs and in computer simulations run with billions of particles, a neural network, a brain, or more precisely, it resembles the kind of emergent structure that appears when any system of interacting elements organizes itself under competing forces over immense periods of time, not because the universe is conscious, but because the same mathematical principles that govern network formation, gravitational attraction balanced against expansion, density fluctuations amplified over billions of years, tend to produce similar geometries, regardless of scale or system. The universe's large-scale structure is not random. It is not chaotic. It is the product of physics playing out across nearly 14 billion years of time, and the result carries an eerie order that sits just below the threshold of what any human observer could have predicted from first principles alone. But the architecture of the cosmic web, and the voids it defines, did not emerge from nothing. Something had to set the initial conditions. Something had to determine where matter would gather and where it would not. Something provided the scaffolding around which filaments condensed and voids hollowed out. And here is where the story of the visible universe, the universe of stars and gas and light and measurable radiation, begins to reveal how thin a surface it actually is. Because the visible universe, the part we can see, the part that emits or reflects or absorbs radiation we can detect, accounts for only a small fraction of the total matter content of the cosmos. When cosmologists count up all the ordinary matter, all the protons, neutrons, electrons, all the atoms that make up every star, every planet, every cloud of gas, and every speck of dust in every galaxy in the observable universe, they find that this tally comes to approximately 5% of the total energy density of the universe. 5%. That number deserves a moment of silence. 5% of everything is the stuff we know. 5% is the universe we have mapped, explored, theorized about, observed with increasingly powerful instruments for hundreds of years. The remaining 95% is something else, something that does not shine, something that does not absorb or emit light, something that does not interact with the electromagnetic spectrum in any way that current instruments can directly detect. And yet it is there. Its gravitational effects are real. Its influence on the structure of the cosmic web is measurable. Its absence from the inventory would make the universe as we observe it physically impossible to explain. The universe is not made mostly of things we can see. The universe is made mostly of things we cannot. That is where the comfortable picture fully collapses. And it does not collapse into chaos, into a shrug of cosmic ignorance, into the convenient admission that science has reached its limits, and the rest is mystery. It collapses into something worse, the suggestion that what we have been watching all along, the glowing galaxies, the luminous filaments, the spectacular nebulae and spinning spiral arms, is not the substance of the universe, but the trace evidence of something deeper, something far more vast, something invisible by nature, that decided the shape of everything and then withdrew from any light we have yet learned to read. The voids are not simply absent of galaxies. They may be absent of the visible component of something much larger, and that something, the unseen architecture beneath what shines, is the real foundation of everything you have ever looked at in the night sky. This is the point at which the familiar story of the cosmos begins to transform into something else, something that requires not just larger numbers, but a different kind of attention. Because the universe is not playing out in the light. It is playing out in regions and substances and forces that operate entirely outside the range of human senses. And the light, the beautiful, intimate, ancient light that falls on your upturned face on a clear night, is not a window into the whole. It is, at best, a narrow aperture into a fraction of the real. There is a particular quality of unease that arrives when a familiar picture is not contradicted, but deepened. When the stars do not disappear but are revealed to be the thinnest layer of a far stranger reality. You have not been wrong to look up and feel the weight of the cosmos pressing down from every direction. You have simply been seeing only what light allows. And the universe, it turns out, keeps most of itself in the dark. To understand what that really means, you have to go further. Further than the stars. Further than the edges of the visible web. Further into the voids themselves. Into the empty architecture at the center of everything, where the universe's true proportions finally become clear. And from that vantage, the story that emerges is stranger, quieter, and far more unsettling than any mere accounting of stars could prepare you for. The voids are waiting. They have always been there. They are not nothing. They are the dominant feature of the cosmos, and they have a story to tell, a structure to reveal, and a future that, when you finally understand it, will make the silence above your upturned face feel like something altogether different from empty. It goes deeper than you have yet allowed yourself to look, and from this point forward, the universe will not be what it was a moment ago. Enter a void, not metaphorically, not as an abstraction. Imagine the transit as literal, as physical, as if you could stand at the filament's edge and step off the last galaxy into the open interior. Behind you, the filament, a strand of matter stretched across hundreds of millions of light years, threaded with clusters and groups of galaxies, lit by the combined glow of trillions of stars, humming with gas and radiation and gravitational complexity. Before you, the void itself. The transition is not dramatic. There is no wall, no threshold you can feel, no change in temperature or pressure, because there is no temperature or pressure to speak of on either side. The filament simply thins. Galaxies grow more widely spaced. The intervals between them stretch. The background glow of clustered light dims with each imagined step forward until you realize, somewhere in the middle of that increasing separation, that you cannot identify the last galaxy behind you with any certainty. The filament has dissolved into distance, and what surrounds you now is something that the mind, trained by a lifetime on a solid planet, is not equipped to process as a real environment. The void does not announce itself. That is the first thing to understand about it. It does not have a color or a texture or a sound. It does not produce the kind of obvious wrongness that triggers alarm in a creature evolved to detect threats. It simply is, with a persistence and scale that accumulates slowly into something far more confronting than sudden danger. You are in a region of the universe hundreds of millions of light years across, in all directions, for distances that make the diameter of the Milky Way look like a rounding error. There is essentially nothing. A few faint dwarf galaxies, perhaps, scattered at densities so low they barely qualify as punctuation in the void's expanse. Thin wisps of ionized gas too diffuse to clump into anything. Photons from distant sources passing through without encountering anything to scatter them or absorb them. The cosmic microwave background, the ancient thermal echo of the early universe, arriving equally from all directions at a temperature of roughly 2.7 degrees above absolute zero. That is the void's ambient condition. That is what fills the dominant volume of the universe. But here is what makes the void something other than mere emptiness, and what makes cosmologists treat it not as an absence to be explained away, but as a structure to be studied on its own terms. The void has shape. It has, in a sense that is genuinely physical rather than metaphorical, an interior. It is bounded not by walls in the solid sense, but by the approaching filaments and sheets of matter that define its edges on all sides. Those boundaries are not sharp or clean. They are gradients, regions where galaxy density slowly increases as you approach the cosmic web's nodes, where gravity has been at work for billions of years pulling matter away from the void's center and toward the intersections and strands of the web. The void is, in this sense, an active region, not a static hole punched into the fabric of the universe. It is a region that has been and continues to be depleted by the same gravitational dynamics that constructed the web itself. The interior of a void is actually, in a subtle but measurable way, underdense relative to the average density of the universe. That may sound redundant, but the implication is not trivial, because density determines the local geometry of space and the local behavior of expansion. In regions of average or above average matter density, gravitational attraction slows the rate at which space expands between objects. In underdense regions, where there is not enough matter to produce significant gravitational drag, expansion runs closer to its unconstrained rate. The interior of a void expands slightly faster than the surrounding cosmic average. The void is not merely sitting in the universe, it is growing, slowly, continuously, and on timescales that make any human reference for long duration feel absurdly compressed. The void is expanding outward, pushing its boundaries toward the filaments, thinning the matter at its edges, enlarging its own emptiness. This is not a violent process. Nothing explodes, nothing tears. The expansion is as quiet as the void itself, a gradual stretching of space that adds distance to distances already incomprehensible. But its cumulative effect over cosmic time is substantial. Voids that were smaller in the early universe have grown to their current enormous dimensions through this slow, relentless self-enlargement. And as the universe ages, as the dynamics that shape the cosmic web continue to evolve, the voids will not fill in. They will not be colonized by matter flowing back from the filaments. Gravity pulls matter toward concentrations, not away from them. The filaments and clusters grow denser at their cores and more depleted at their edges. The voids grow emptier at their cores and more clearly bounded at their edges. The contrast between the two deepens over time. The universe's structure is not moving toward homogeneity on the scales that matter for cosmic evolution. It is moving toward more extreme differentiation. Denser dense regions, emptier empty regions, and the voids asserting their dominance by sheer volume with every passing billion years. Now consider the cosmic web itself from outside, as a complete structure visible in its totality, and what you see is something that no human architect has ever designed, but that physics, given enough time and the right initial conditions, assembles with consistent geometry across the entire observable universe. The web consists of filaments, sheets, clusters, and voids. The filaments are the highways, the long linear structures along which galaxies are strung by gravity over hundreds of millions of light years. The sheets are the two-dimensional walls where several filaments intersect in a plane rather than a point, flatter and less concentrated than filament intersections, but still significantly overdense compared to void interiors. The clusters are the nodes, the gravitationally dominated regions at the intersections of multiple filaments where hundreds or thousands of galaxies are bound together, and where the most extreme matter densities in the universe are found. And then the voids, occupying all the volume that is not filament, sheet, or cluster, occupying in fact most of the volume that exists. The geometry that emerges from these components, when you see it rendered in the outputs of computational models that simulate the formation of cosmic structure across billions of years, is deeply strange to encounter. It looks simultaneously organic and mathematical. It looks like something that grew rather than something that was built. And in a meaningful sense, both of those descriptions are correct. The cosmic web grew, through physics, through the amplification of minute density variations that existed in the early universe, within the first fractions of a second after the beginning, amplified by gravity over billions of years into the differentiated filamentary void-dominated structure visible today. The growth was not random. The rules governing it, gravity, expansion, the distribution of initial density fluctuations, are deterministic within the bounds of what cosmological models currently describe. The web that exists is, in some deep sense, the specific web that had to exist given those initial conditions and those physical laws. But it gets worse. because the story of how the cosmic web formed, and why its voids are where they are, and its filaments are where they are, cannot be told using ordinary matter alone. When cosmologists run simulations using only the matter that emits or interacts with light, ordinary baryonic matter, protons, neutrons, electrons, all the atomic material that composes stars and gas and the surfaces of planets, the simulations fail. The web that forms from ordinary matter alone does not match the web that we observe. The filaments are wrong. The clusters are wrong. The distribution of galaxies is wrong. The simulations miss the observed structure by margins that cannot be dismissed as rounding errors or model imperfections. Something essential is absent. Add a different kind of matter. Matter that does not interact electromagnetically. Matter that cannot be seen or directly detected but that has mass and therefore exerts gravitational influence. And the simulations converge on something that looks, in its broad structural properties, like the universe we actually inhabit. The filaments align. The cluster masses become plausible. The void distributions fall into reasonable correspondence with observation. The addition of this invisible matter does not merely improve the models. It is the difference between a simulation that produces a recognizable cosmos and one that produces something that bears no coherent relationship to reality. This invisible matter is dark matter. The name is the only name it has, because everything else about it remains uncertain. It does not emit light. It does not absorb light. It does not scatter light. It has no known interaction with the electromagnetic force through which almost all of our sensory and instrumental contact with the universe is mediated. It passes through ordinary matter without colliding. It does not form stars because star formation requires gas to radiate energy and cool and contract, and dark matter, lacking the ability to radiate, cannot participate in that collapse. It exists, as far as current understanding reaches, only gravitationally. It pulls. It shapes. It accumulates in halos around galaxies and at the nodes of the cosmic web. It concentrates along filaments. It contributes the dominant share of the gravitational mass in galaxy clusters. And it does all of this without ever announcing its presence in any frequency of the electromagnetic spectrum. Consider what that means for the cosmic web. The filaments that can be seen in galaxy surveys, the strands of light connecting clusters across hundreds of millions of light years, are not primarily composed of ordinary matter. They are outlined by it. The actual structural mass of the filaments, the gravitational backbone that keeps them coherent and extended and connected to the nodes they bridge, is dark matter. The galaxies and gas are attached to a dark scaffolding, the way frost on a window traces the shape of an underlying structure it cannot create on its own. The frost is visible, the structure beneath it is not, but the frost's pattern is entirely determined by what lies beneath, and this scaffolding extends into and around the voids as well. Even in the emptiest regions of the cosmic web, dark matter is not entirely absent. It is simply less concentrated. Its density drops in the void interiors, just as ordinary matter's density drops, but the drop is not to zero. The voids are defined by their ordinary matter underdensity, but even their interiors thread through what might be described as a thin, dark substrate of minimal gravitational structure. This is one of the ways in which the distinction between the void and the filament is revealed to be a matter of degree, rather than kind. The void is not where dark matter stops. It is where dark matter thins to its near minimum, while the filaments and clusters are where it reaches its near maximum. The whole universe is permeated by it. The void is simply the region where it has least preferred to gather. Why dark matter distributes the way it does, why it concentrates in halos and filaments and avoids void interiors, comes back to the same physics that shapes the cosmic web's ordinary matter component. Gravity attracts matter to matter. Where density begins slightly higher, gravity is slightly stronger, attracting more matter, which increases density further, which strengthens gravity more. Over billions of years, this feedback process amplifies initial density variations into the pronounced structures of the web. Dark matter, with no other force competing against gravity, no gas pressure, no radiation pressure, no thermal motion strong enough to resist gravitational collapse, is actually more efficiently organized by gravity than ordinary matter. It collapses earlier and on smaller scales. It forms halos before the ordinary matter inside them even begins to cool and condense into the first stars. The dark matter structure precedes the visible structure. The scaffolding goes up first. The luminous matter follows. This reversal of expectation is one of the most quietly disorienting things in modern cosmology. We observe the universe through light. We map it through electromagnetic signals. Every image ever taken of the cosmos, every radio map and infrared survey and X-ray observation, captures the behavior of the 5%. The remaining 95% leaves its mark only through gravity, only through the distortion of space-time and the bending of light, and the dynamics of orbiting objects that betray the presence of mass beyond what is visible. To see the dark matter, we must infer it from the behavior of things it is not. We must read the universe in its shadows, in the residuals, in what the visible matter does that it could not do if it were alone. This is not a comfortable epistemological position. It is not the kind of knowledge that feels solid and direct. It is the knowledge of a detective working entirely from secondary evidence, who has never encountered the primary subject directly, and who must construct a reliable account of something that leaves only indirect marks on everything around it. The confidence in dark matter's existence is high because its indirect marks are consistent, pervasive, and resistant to other explanations. But the nature of dark matter, what it actually is at the particle level, whether it is one kind of particle or many, whether it has any non-gravitational interactions too weak for current instruments to detect, remains one of the most genuinely open questions in fundamental physics. The matter that shapes everything is, in the most literal sense, unknown matter. It gets worse, because dark matter, as mysterious as it is, at least behaves in ways that are conceptually familiar. It has mass. It exerts gravity. It clusters. It has a distribution that can be modeled and that matches observations with impressive accuracy. It is the invisible part of a familiar story, the story of matter organizing itself under gravity over time, strange in its identity, but operating within a framework that cosmologists can work with. Dark matter is at least doing something we recognize from a gravitational standpoint, even if we cannot identify what it fundamentally is. Dark energy is different. Dark energy does not cluster. Dark energy does not behave like matter at all. Dark energy is, as far as current cosmological evidence indicates, an intrinsic property of space itself, a constant energy density associated with the vacuum, which does not dilute as the universe expands and whose effect is not to attract but to drive expansion, not slow expansion, not stable expansion, accelerating expansion. And this changes everything about the long-term trajectory of the universe in ways that are not merely dramatic but, when followed to their logical conclusion, profoundly and quietly catastrophic. To understand why, consider the history of cosmic expansion. When the universe began, whatever beginning means in the context of a physical event for which no prior state can be described with current physics, it did so in a state of enormous energy density and fantastically compressed scale. In the moments and years following that beginning, the universe expanded. This is not a controversial statement. The evidence for cosmic expansion, the redshift of distant galaxies, the cosmic microwave background, the measured abundances of light elements, is among the most robust in all of modern science. Space itself stretched. The distances between points in space grew. Galaxies that were once near one another are now far apart, not because they moved through space in the conventional sense, but because the space between them expanded. The distinction matters. Objects moving through space are limited by the speed of light. Space expanding carries no such limit. Two regions of the universe can separate from one another faster than light travels, not because anything in them exceeds the speed of light, but because the space between them is itself growing at a rate that accumulates to superluminal recession at sufficient distances. In the early universe, this expansion competed with gravity. The universe was dense, and dense meant gravitationally active. Matter attracted matter. Gravity worked against expansion, slowing it. For billions of years, cosmologists expected that the deceleration would either slow expansion to an asymptotic halt, or, if the total matter density were high enough, reverse it entirely, eventually pulling the universe back into a contracting phase. Neither of these expectations was confirmed by observation. In 1998, results from two independent research groups studying the brightness of type Ia supernovae at cosmological distances revealed something that was not expected at all. Distant supernovae were fainter than they should have been if expansion were decelerating. The universe was not slowing down. It was speeding up. Expansion was accelerating. The data were not marginal or ambiguous. The acceleration was real, and its implications restructured cosmology almost overnight. Something was driving the acceleration. That something, whatever it is, was given the name dark energy. It represents, in the current cosmological model known as lambda CDM, approximately 68% of the total energy density of the universe. It is the dominant component of the cosmos. More than twice as much of the universe, by energy density, is composed of this accelerating agent as is composed of all matter, visible and dark. combined. The universe is not primarily made of stars. It is not primarily made of dark matter. It is primarily made of an energy that accelerates the expansion of space, and that is, in its fundamental nature, entirely uncharacterized by any theory that has yet achieved experimental confirmation. The name we give it is not a description. Dark energy is a placeholder, a label applied to the observational fact of accelerating expansion pending an actual physical explanation. The most mathematically natural candidate is the cosmological constant, the energy density of the vacuum itself, a term that Einstein introduced and later withdrew and that quantum field theory independently predicts, albeit with a theoretical value that is catastrophically different from the observed value, a discrepancy that remains one of the most embarrassing unsolved problems in theoretical physics. The universe accelerates, and we know that it does, and we can describe the acceleration precisely in its geometric and observational effects, and we genuinely do not know why. We have a term in our equations. We do not have a theory that explains it from first principles, but it goes deeper, because the question of what dark energy is, while genuinely important for fundamental physics, is in some ways secondary to the question of what it does. And what it does, what it is doing right now, and what it will continue doing on timescales that make the current age of the universe look like a preface, is separate every gravitationally unbound structure from every other gravitationally unbound structure, permanently and irreversibly, by expanding the space between them faster than any force can bridge the growing gap. Every galaxy that is not gravitationally bound to our local group, and that means the overwhelming majority of the 2 trillion galaxies in the observable universe, is already moving away from us. Not because galaxies have peculiar velocities driving them apart, though those exist too, because the space between us and them is expanding, and because dark energy maintains and accelerates that expansion. The recession velocity of distant galaxies is not constant, it grows. The further a galaxy is, the faster it recedes. At a sufficient distance, the recession velocity exceeds the speed of light, and the light from that galaxy can no longer reach us. That galaxy passes beyond what cosmologists call the cosmic event horizon, the boundary beyond which events can no longer influence our location in any future time. Once a galaxy crosses that horizon, it is gone from us, not destroyed, not moved, simply separated by a distance that expansion will never allow light to cross. This is happening now. This has been happening for billions of years. Galaxies are crossing our cosmic event horizon continuously. The observable universe is not static. It is shrinking, not in physical size, not in the number of galaxies it contains at any given moment, but in the number of galaxies it will ever be able to contain in the future. The universe is not closing in on us. It is opening up, becoming more spacious, but becoming spacious in the specific way that puts everything at increasing distances that light, and therefore any signal, any force except gravity over very short timescales, can never cross. And this leads to something more disturbing. The cosmic web, the structure whose emergence we have traced from tiny density fluctuations in the early universe to the immense filaments and voids visible in galaxy surveys today, is itself subject to this separation. On small scales, within gravitationally bound structures, expansion is irrelevant. The Milky Way will not expand. The local group will not expand. Even the Virgo supercluster, held together in part by the gravitational dominance of its central cluster, will not simply fly apart. Gravity, on scales small enough for it to dominate dark energy, holds structures together against the expansion. But between superclusters, between the large nodes of the cosmic web, where gravity is insufficient to overcome the expanding background, the separation grows. The filaments that connect clusters across cosmological distances will stretch and thin over cosmic time. The web will not collapse. It will diffuse. Its long-range connections will lengthen until they cease to be connections in any meaningful sense. The cosmic web, whose architecture took billions of years to construct from the gravitational amplification of tiny initial fluctuations, will not persist as a coherent structure indefinitely. Its large-scale geometry will be erased by the same expansion that once allowed it to grow. The filaments will elongate until their densities drop too low for them to function as highways of matter and light. The voids will grow. The distances between the gravitationally bound islands, the local groups and clusters that will survive as isolated structures, will become too great for any signal or influence to travel between them. What took the universe billions of years to assemble will be unmade, not by force, not by heat, not by collision, but by distance, by the patient, invisible, relentless growth of space. There is a particular way in which the void, revisited in light of these dynamics, changes its character entirely. The void was, in the context of the cosmic web's present architecture, a region of absence surrounded by structure. The filaments defined its edges. The clusters marked its corners. The web gave the void meaning by contrast, the way a frame gives a canvas its boundary. But as expansion separates the filaments and the clusters, as the long threads of the web stretch and thin, and eventually become too diffuse to qualify as structure, the relationship between void and filament will blur. The exceptional nature of the void's emptiness will become less exceptional because the universe around it will increasingly resemble the void itself. The emptiness will not fill in. The fullness will empty out. This is the quiet catastrophe that dark energy is already engineering across the cosmos. Not a sudden rupture, not an explosion. A long, gradual, geometrically inevitable separation of everything from everything else. The universe's most defining feature is not its light. It is its expansion, and the expansion is accelerating. And the acceleration means that the future universe is a lonelier place than the present one, and the present universe is already overwhelmingly lonely. The voids, then, are not simply the universe's past or present. They are its future. They are the template toward which the universe is moving. What the void is now, nearly empty, nearly uniform, nearly featureless, the rest of the accessible universe will approach over timescales that no civilization, however advanced, is likely to survive long enough to observe directly. But the physics does not care about observers. It moves forward regardless of whether anyone is present to register its direction, and the direction is clear. To stand at the edge of a cosmic void today is to stand at the edge of a future that is already inevitable for most of the universe. The void is not where things end up after something goes wrong. The void is what the universe mostly is, what it increasingly is, and what it tends to become. The light, the structure, the filaments, the clusters, the entire glowing architecture that seemed from a distance and from the vantage of a small planet to be the universe in its fullness is the exception. It is the temporary, locally concentrated, gravitationally produced exception to a cosmic rule that is written in the geometry of an expanding spacetime dominated by an energy no one yet understands. And this exception, this thin layer of luminous structure clinging to the scaffolding of dark matter at the intersections of a web that expansion is already beginning to unravel, is not permanent. Its future is shaped not only by the dynamics we have discussed, not only by dark energy and the cosmic web and the growing distances between gravitational islands. Its future is shaped by something even quieter, even more fundamental, even more relentless in its direction, something that does not require dark energy to do its work, because it is written into the behavior of matter and energy at the most basic level of physical law, something that operates not across billions of light years, but within every star, every atom, every interaction and every structure in the universe, something that has been eroding the universe's capacity for complexity and meaning since the first moment of existence, and that has never, in the entire history of the cosmos, moved backward by a single step. It has many names and contexts. In thermodynamics, it is the second law. In cosmology, it is the arrow of time. In the quiet of a void's interior, it is the reason the void will never reverse, never fill, never warm. It is the reason all the energy that ever existed in the universe is not simply redistributed, but gradually and permanently degraded into forms less capable of doing anything at all. It is the current beneath everything, invisible and absolute, and it is flowing in only one direction. And where it is flowing on the longest timescales is somewhere that makes even the present vast emptiness of the cosmic voids feel, by comparison, like the interior of a crowded room. Entropy is not a concept that arrives with drama. It does not announce itself the way a supernova announces itself, with light bright enough to outshine an entire galaxy for weeks. It does not have a visible signature, no color, no pulse, no identifiable moment of onset. Entropy is the direction in which time runs. It is the reason a broken object does not spontaneously reassemble. It is the reason a cold room does not grow warmer by drawing heat from a cooler object inside it. It is the reason every process in the universe that produces something useful, that concentrates energy into a form capable of doing work, leaves behind a residue of degraded, dispersed, less useful energy that can never be fully recaptured. Entropy is not what happens when things go wrong. It is what happens when things happen at all. Every event in the history of the universe has increased the total entropy of the universe, not by the same amount in every case, not always perceptibly, but always in the same direction. Cosmologists and physicists sometimes describe entropy in terms of disorder, and while this framing captures something real, it can mislead as easily as it illuminates. The word disorder suggests chaos, randomness, the collapse of pattern into noise, and entropy does move in that direction, in a statistical sense. But a more precise and useful way to think about it is in terms of available states. A system with low entropy is one where the arrangement of its components is constrained to a relatively small number of possible configurations. A system with high entropy is one whose components are distributed across a vastly larger number of possible configurations. The universe, from the moment of its beginning, has been moving from a state of extraordinary constraint, extraordinary low entropy, toward a state of far greater statistical freedom, higher entropy. Every star that burns, every chemical reaction that releases heat, every gravitational contraction that generates radiation, moves this count in the same direction, toward more ways for things to be arranged, toward less constraint, toward less capacity for useful work. In practical terms, this means energy spreads. Heat flows from hot regions to cold ones. Radiation disperses outward from its source. Chemical gradients equilibrate. Pressure differentials equalize. The universe is full of these processes happening simultaneously at every scale, and each one is a small contribution to the total entropy of a cosmos that is, in the aggregate, moving from a highly ordered low-entropy early state toward a highly disordered, high-entropy future state. The structures that seem permanent from a human perspective, stars, galaxies, the cosmic web itself, are not immune to this direction. They are temporary concentrations, local low-entropy pockets maintained by the continuous expenditure of energy, surrounded on all sides by the universe's relentless tendency toward equilibrium. Consider the sun. It is, from the perspective of life on the surface of a nearby planet, a stable and enduring object. It has burned for approximately 4.5 billion years. It will continue burning for roughly another 5 billion years. On any human timescale, this is effectively permanent. But on the timescale of the universe, the sun is not permanent. It is a process. It is nuclear fusion, the combination of hydrogen nuclei into helium, and then into heavier elements, releasing energy that was stored in the mass difference between the reactants and the products. That energy, once released, flows outward as radiation. It leaves the sun. It disperses into the solar system and beyond. It is not returned to the sun. The sun's hydrogen is being consumed irreversibly, and when it is gone, the sun will not simply restart. It will evolve through the red giant phase, expanding enormously, and eventually shed its outer layers and collapse into a white dwarf, a dense, hot remnant of a star that is no longer fusing anything, no longer producing energy, simply cooling. A white dwarf cools over time. It radiates the heat of its formation into the surrounding space, and that radiation disperses and does not return. Given sufficient time, a white dwarf cools to the point where its thermal radiation becomes negligible, theoretically over timescales so vast that they make the current age of the universe seem negligible. A sufficiently cooled white dwarf would become a black dwarf, a cold, dark, inert mass of degenerate matter, no longer emitting any significant radiation, sitting in the dark, a monument to a star that once burned and warmed and structured its local environment with the force of its luminosity. Black dwarfs do not yet exist in the universe, because the universe is not old enough. The cooling time for white dwarfs exceeds the current age of the cosmos by orders of magnitude, but they are coming. They are the future of nearly every star that does not end its life in a supernova. This is the direction in which the stellar population of the universe is moving, not toward greater luminosity, not toward more stars and more light and more energy, but toward less. The history of star formation in the universe has a peak, a period during which new stars were forming at the highest rate in cosmic history. That peak occurred roughly 10 billion years ago. Since then, the rate of star formation has declined. The universe is making fewer new stars than it used to. The gas reservoirs that feed star formation in galaxies are being consumed and not fully replenished. Over time, galaxies will run short of the cold, dense gas required to collapse into new stars. The star formation rate will continue to decline, not to zero overnight, not even over millions of years, but over billions, and eventually trillions of years. The last new stars will form, and when they do, no more will follow. The universe, then, is not in a steady state. It is not maintaining its current population of stars while continuously replacing the ones that die. It is working through an existing supply of star-forming material that is being permanently consumed, that was fixed at some early time, and has been decreasing ever since. The night sky, which seems to a human observer to be a permanent fixture of the cosmos, is a snapshot of an era defined by active nuclear burning, by luminous stellar populations, by the kind of starlight that makes a clear night feel populated and warm. This era will end. It will end not with a dramatic extinguishing, but with a gradual fading, as the last star-forming regions exhaust their gas, as the last small red dwarf stars, the most fuel-efficient stellar class in the universe, burn through their hydrogen over trillions of years and settle into the cooling silence of their remnant states. But it gets worse, because stellar evolution is only one thread in the entropy story. The fading of starlight is only the most visible indicator of a universe moving toward less available energy, less structural complexity, less capacity to maintain the local order that makes interesting things possible. The rest of the story plays out on even longer timescales, in even darker and quieter conditions, and it involves the objects that remain after the stars are gone. Stellar remnants are not permanent structures in the full sense. White dwarfs cool toward black dwarfs over timescales of perhaps 10 to the 15th years or longer. Neutron stars, the dense remnants of more massive stars that ended their lives in supernova explosions, are even more compact and initially much hotter, but they too cool over time, radiating away their thermal energy into the surrounding dark. And then there are the black holes, the objects formed from the most massive stellar progenitors, and from the mergers and accretions of matter in galactic centers that represent the extreme outcome of gravitational collapse. Black holes do not cool in the ordinary sense. They do not have a surface that radiates thermally in the way a white dwarf does, but they are not immune to entropy. They are not immune to time. Stephen Hawking's theoretical work in the 1970s established that black holes should emit a form of thermal radiation, now called Hawking radiation, arising from quantum mechanical effects near the event horizon. This radiation is extraordinarily faint for any black hole of stellar or larger mass, so faint that it would be completely undetectable against even the coldest cosmic background. But it is real, at least according to the theoretical framework that produced it, and its consequence is that black holes slowly lose mass through this process. Over timescales that are, by any measure, incomprehensibly long, a black hole will radiate away its entire mass and evaporate completely. The timescale for a stellar mass black hole to evaporate through Hawking radiation is estimated at roughly 10 to the 67th years. A supermassive black hole, of the kind found at the center of large galaxies with masses of billions of solar masses, would take far longer, perhaps 10 to the 92nd years or more, depending on its mass. These numbers are not merely large, they are large in a way that makes every other large number in astronomy seem like a moment. The current age of the universe is approximately 14 billion years, or roughly 10 to the 10th years. The evaporation time of a supermassive black hole exceeds that by more than 80 orders of magnitude. The universe would have to exist for that long without any significant input of new energy, without any new stars, without any new structure forming, just the gradual cooling and thinning of everything that remains. And if current models are correct, if proton decay is a real process occurring on timescales predicted by certain grand unified theories, then ordinary matter itself is not permanent. Protons, the stable building blocks of atomic nuclei, may decay over timescales of roughly 10 to the 34th years or longer, depending on which theoretical model, if any, correctly describes the underlying physics. This remains unconfirmed experimentally, and it is worth being precise. Proton decay has not been observed, but some theoretical frameworks that extend the standard model of particle physics predict it. If it occurs, then even the cold, dark remnants of stars that never became black holes, the black dwarfs, the cooled neutron stars, the frozen planetary bodies drifting through the dark between galaxies, will eventually dissolve into lighter particles and radiation, over timescales so immense that the word timescale itself starts to feel like a category error. There would be nothing left of solid matter, only particles, radiation, and the slowly evaporating black holes. This is the trajectory of the universe under the second law of thermodynamics and the physics of stellar and structural evolution, not toward destruction, not toward a dramatic collapse, but toward a state called heat death, or more precisely, thermodynamic equilibrium. Heat death is not hot. The name is historical and perhaps misleading. It refers to a state in which all available temperature gradients have been exhausted, all energy differentials have been equalized, all the hot-cold, dense-sparse, structured-unstructured contrasts that allow work to be done and processes to occur have been flattened into a uniform distribution of low-density, low-temperature energy, spread thinly and evenly across an enormously expanded universe. It is not a universe that ends. It is a universe that arrives at a state from which nothing further can depart. The condition this describes is not silence in the metaphorical sense. It is silence in the most literal physical sense. There are no processes occurring. There is no sound, because sound requires a medium with pressure variations, and there are no pressure variations. There is no light, because light requires a source, and there are no sources. There is no heat flow, because heat requires a temperature gradient, and there are no gradients. There is only the faint thermal noise of a universe in perfect equilibrium with itself, a near absolute zero background spread across a space that has expanded for so long that its scale bears no meaningful relationship to the universe of today. It is a state so close to nothing that the distinction between it and nothing may be more philosophical than physical. This is the future that entropy is building, one exhausted process at a time, one cooled remnant at a time, one dispersed photon at a time. And it is worth sitting with the full implication of that for a moment, because the tendency in discussing these things is to reach for the comfort of abstraction, to say yes, the far future is bleak, but it is so far away that it is irrelevant to anything that matters, and to move on without feeling the weight of it. But the weight is there. The direction is already established. Every star burning right now is contributing to this end. Every galaxy cluster that radiates X-rays into the surrounding space is contributing to this end. Every photon that escapes into the expanding void and redshifts to lower and lower energy as space stretches is contributing. The end point is not a future possibility. It is a physical consequence of the present, extended forward without interruption. But there is a layer to this story that has not yet been fully confronted, one that operates not at the level of thermodynamics or stellar physics, but at the level of information, observation, and knowledge. A layer that turns the physical trajectory of the universe into something that is not merely vast and cold and dark, but that directly concerns the relationship between what can be known and what will exist to know it. This layer is about horizons, about the limits of the observable universe and how those limits change over time, about the possibility that the physical future of the cosmos is one in which the evidence for its own past is progressively erased, not destroyed, but carried beyond reach, swept past the edge of what any observer in any location could ever detect, a future in which the universe becomes, for any observer within it, not merely lonely but epistemically truncated, a future in which knowing the full scope of reality is not merely difficult but physically impossible, not because the knowledge was never there, but because the universe has expanded it away. To understand why this matters, consider the situation of any hypothetical civilization far in the future, perhaps 100 billion years from now, perhaps 1 trillion years. They exist within a gravitationally bound structure, perhaps the remnant of a galaxy group that has merged into a single large elliptical galaxy over the billions of years since its component galaxies coalesced, held together against the expansion by the gravitational dominance of their combined mass and dark matter halo. They look outward with whatever instruments their physics allows them to construct, and what they see is not what we see. Every galaxy beyond their local gravitational island has, by this point in cosmic history, receded beyond the cosmic event horizon. The light from those galaxies, which was traveling toward them when the galaxies first became separated from the local group, has been progressively redshifted and dimmed by the expanding space it traversed. The last photon that can ever arrive from any given external galaxy is the one that was emitted at a moment close enough to the present, cosmologically speaking, to make the journey before the expansion of space made the journey impossible. After that photon arrives, there is no more information, there is no more signal, there is no more evidence that those galaxies ever existed. The cosmic microwave background, the ancient thermal radiation that permeates the entire observable universe today, and that serves as one of the primary windows into the universe's early history and large-scale structure, will also redshift over time. As the universe expands, the CMB's photons lose energy. Their wavelengths stretch. Their temperature, already extremely low, drops further. In the far future, the CMB will be redshifted to wavelengths so long and energy so low that detecting it would require instruments sensitive beyond any plausible extrapolation of technology. It will not vanish physically, but it will become, for any practical observer, undetectable. The background signal that today tells us about the first light of the universe, that encodes the density fluctuations from which the cosmic web grew, will be gone from accessible observation. And this leads to something more disturbing. A civilization in the far future, intelligent, observationally sophisticated, equipped with technology beyond anything present science can anticipate, will look out and see essentially nothing beyond their own gravitational island. They will have no observational evidence that a larger universe exists. They will have no data from which to reconstruct the cosmic web. They will have no signal encoding the existence of 2 trillion galaxies distributed across the observable universe. They will have no CMB to tell them about the early universe, no red-shifted light from distant sources to tell them that space is expanding, no supernova at cosmological distances to tell them that the expansion is accelerating. From within their isolated island, the universe will appear to be exactly what it looks like from inside, a single galaxy, or small group of galaxies, surrounded by dark and empty and essentially infinite space. They might conclude, from this observational evidence, that the universe is simply a small island of matter in an infinite dark expanse. They might construct a cosmology that matches their observations perfectly, and that is, by the standards of what they can detect, scientifically rigorous and internally consistent, and that is profoundly, irreversibly wrong about almost everything, not through any fault of their reasoning, not through any failure of their instruments or methodology, but because the universe will have expanded the evidence away. The universe will have placed the truth beyond any horizon they can ever reach. The physical history of the cosmos, the cosmic web, the 2 trillion galaxies, the CMB, the evidence for the Big Bang, will not be hidden behind a door they lack the key to open. It will be physically outside the causally connected region of space that encompasses their entire existence. This is what it means for the universe to erase its own history, not through the destruction of records, but through the inexorable expansion of the space that separates records from observers. The universe is a place where the evidence for what happened is physically transported beyond reach, not by entropy alone, not by time alone, but by the geometry of an accelerating expansion that continuously shrinks the portion of reality any observer can access. What we can see today, the entire rich, complex, structured, filamentary, void-punctuated cosmic web, visible in the deepest galaxy surveys, will eventually be observable from no future location within the universe. It will exist in the sense that matter and energy are conserved and nothing is truly destroyed, but it will be unreachable, unknowable, functionally non-existent for any observer who comes after the last light has receded. We are living in a cosmologically privileged moment, not privileged in any anthropocentric or predetermined sense, privileged simply in the sense that the universe is currently structured, currently populated with accessible evidence, currently observable in enough of its breadth and depth that a civilization on one small planet has been able to reconstruct, with remarkable accuracy, the history and structure of everything from the first fraction of a second after the beginning to the large-scale architecture of the cosmic web, billions of light years in every direction. That privilege is not permanent. It is a window defined by where expansion has placed the cosmic horizon relative to the content of the observable universe, and that window is closing, slowly, on timescales that make any human planning horizon irrelevant, but closing. Every year galaxies cross our cosmic event horizon. Every year photons that were the last to escape some distant source arrive and are absorbed and are gone. Every year, the inventory of accessible cosmic history becomes slightly smaller. The universe is not hiding its past from us. It is outrunning our ability to receive it, and the rate of that outrunning is not decreasing. It is increasing, because the expansion is accelerating, because dark energy maintains and strengthens its influence over cosmic time, because the horizon is not a fixed boundary, but a dynamic one that moves in a direction consistently unfavorable to the persistence of accessible information. There is a kind of loneliness in this that is not emotional in the ordinary sense. It is structural. It is written into the geometry of an expanding universe dominated by dark energy. It is the loneliness of a bounded observer in an unbounded space, aware that the boundary around them is not chosen but imposed, not temporary but permanent, not the edge of the known world in the historical sense, not a frontier awaiting exploration, but a genuine horizon beyond which the physics of light and space make contact forever impossible, not difficult, not expensive, not beyond current technology. Impossible, in the absolute sense, because the space between has expanded faster than light can cross it, and will continue to expand faster than light can cross it for all future time. The universe that an observer in the very far future inhabits is not a degraded version of the universe we inhabit today, in the way that a worn-down city is a degraded version of its former self. It is a structurally different kind of place, a place where the very observational foundations required to determine that the universe has a history, that it once contained more than a single gravitational island, that it had a beginning and a large-scale structure, and a cosmic web, and 2 trillion galaxies and the CMB and all the rest, are simply absent. Not inaccessible due to technological limitation. Absent because no photon encoding that information can ever reach that observer's location from any direction, from any distance, at any speed, in any amount of time. And yet those observers, if they exist, will not feel themselves to be in a diminished universe. They will feel themselves to be in the universe, the full universe, the only universe their instruments and their physics can reach. And their universe will be cold and dark and mostly empty, and lit only by the dim remnants of whatever stellar objects still persist in their final evolutionary stages. And they will be entirely unaware that what they are experiencing is not the whole of reality but its final chapter. Read in near total darkness, without access to any of the preceding pages. This is the consequence that accelerating expansion is building toward, and it is not separable from the dynamics of the voids, from dark matter's invisible architecture, from entropy's quiet direction, from the long fading of stellar populations. All of these threads are part of the same story, a universe that began in an extraordinary state of low entropy and high density and rich structure that expanded and cooled and organized itself into a cosmic web of breathtaking complexity, and that is now, under the combined influence of dark energy and thermodynamic law, moving steadily toward a state of maximum entropy, maximum separation, minimum structure, and minimum accessible information. The story is not finished. It is not close to finished. By any measure of elapsed cosmic time, we are extraordinarily early, but early does not mean safe from the implications of the trajectory. The direction is established. The physics is clear enough in its general outline that the end point, though specified in detail only approximately and with appropriate scientific uncertainty, is not in significant doubt. The universe is becoming lonelier. It is becoming darker. It is becoming less connected, less structured, less knowable. And it will continue in that direction until the last remnants of the last stars have cooled past any meaningful temperature differential, until the last black holes have evaporated over immensities of time that language was never built to contain, and until the heat death, if it is indeed the fate that awaits, arrives in a state of such perfect and complete thermodynamic equilibrium that the distinction between the universe existing and not existing becomes, for all practical, and perhaps all theoretical purposes, irrelevant. There is a particular moment in any investigation of the cosmic long-term future when the mind attempts to retreat into the comfortable familiarity of the present. The stars are burning. The galaxies are there. The CMB is detectable. The cosmic web is visible in its full complexity. None of what has been described has happened yet, and that is true. But the purpose of following the physics forward is not to induce premature despair about events billions of trillions of years in the future. It is to understand what the universe actually is, what its structure reveals about its direction, what the emptiness of the voids and the invisible architecture of dark matter, and the accelerating influence of dark energy, and the irreversible direction of entropy are collectively saying about the nature of the place in which everything we have ever known has occurred. What they are saying is this: the universe is not a stage set for permanence. It is not a backdrop against which events occur and then are preserved. It is a physical system in time, subject to physical laws, moving in a physical direction. That direction is toward less energy, less structure, less contrast, less connection, less accessible information, and eventually, if the trajectory holds, toward a state so close to absolute thermodynamic silence that no signal, no thought, no observation, no measurement could distinguish it from the end of everything meaningful. Not destruction, not explosion, not a dramatic finale. Simply the long, cold, geometrically perfect dissolution of everything that was ever bright enough to be seen from the surface of a small planet on a clear night. You have been standing under the night sky again. You have been looking up at the stars, at the galaxies that blur into a faint smear across the Milky Way's band, at the incomprehensible depth of a universe that presents itself as full and close and permanent, and none of that is wrong. Precisely, the light is real. The stars are there. The galaxies exist. But the universe they inhabit, the one revealed when you follow the physics into its full implications rather than stopping at the beautiful surface, is a place defined not by its light, but by its emptiness, not by its structure but by the spaces between its structures, not by its past, but by the direction of its future. And that future is dark in a way that has nothing to do with fear or mythology or the instinctive unease of a creature that evolved in the light. It is dark because dark is what the physics produces, given enough time, and the universe has all the time there is. There is a specific kind of silence that belongs to a room after everyone has left. Not the silence of a room that was never occupied, which is simply the baseline condition of an empty space, but the silence of a room that was full, that had voices and heat and movement and the particular density of presence that living things carry with them, and that is now empty. The objects remain, the walls remain, the geometry of the space is unchanged, but something has departed that the space itself cannot restore, and the silence it leaves behind has a quality that distinguishes it absolutely from the silence that preceded occupation. It is the silence of aftermath, the silence of what follows having been. The universe is moving toward that silence, not quickly, not on any timescale that a civilization could plan around or an individual could feel personally threatened by. But the direction is not ambiguous, and the destination, if the physics holds, is something that resembles the silence of aftermath more closely than any other analogy that human experience can supply. It is the silence of a place that was once structured and luminous and complex and that has, through the patient operation of physical law, become none of those things. A place where everything that once happened cannot happen again, not because it is forbidden, not because it has been destroyed, but because the conditions that made it possible have been irreversibly exhausted. To approach this destination with the seriousness it deserves, consider what the universe looks like not at its current age of 14 billion years, but at 100 times that age, 1.4 trillion years. By this point in cosmic history, something fundamental about the observable universe has already changed beyond recovery. The accelerating expansion driven by dark energy has been at work for the full span of that time. Galaxies beyond the local gravitational cluster have long since vanished beyond the cosmic event horizon. The number of galaxies accessible to any observer has been reduced, from the current roughly 2 trillion to the population of a single merged structure, the gravitational remnant of what was once the local group. The Milky Way and Andromeda will have long since collided and merged, an event expected within the next few billion years, producing a single large elliptical galaxy, sometimes informally called Milkomeda. This merged structure, along with the smaller satellite galaxies gravitationally bound to it, will constitute the entire accessible universe for any observer unfortunate enough or fortunate enough to exist at this epoch. The sky above such an observer, if they look outward, is dark. Not the merely dark sky of a modern night, punctuated by thousands of stars and a faint galactic band, dark in the absolute sense. No external galaxies, no distant light sources, no cosmic microwave background detectable by any instrument they might construct. The void outside their gravitational island is not the void of empty space between galaxies in a populated cosmos. It is the void of a universe that has moved everything else beyond reach. Their sky is the sky of a place that has been fully isolated by geometry, and the isolation is permanent. But within their island, within the merged remnant of the local group, there are still stars, fewer than today, significantly fewer. The great spiral arms that once swept through the Milky Way and Andromeda, forming new generations of stars from their gas clouds, have long since merged into the smooth, featureless stellar distribution of an elliptical galaxy. The gas reserves that once fed star formation have been largely consumed. New star formation is rare, occurring only where small pockets of sufficiently dense and cool gas remain, and even those pockets are becoming rarer with each passing billion years. The stars that were born in the era of peak star formation, the short-lived massive blue stars, have long since exploded and left behind their neutron stars and black holes. The sun-like stars have run through their main sequence lifetimes and evolved through their giant phases and settled into white dwarfs, cooling slowly in the dark. What remains in the stellar census of this future galaxy is dominated by the most frugal fuel consumers in existence, the red dwarf stars. Red dwarfs are the most common type of star in the universe today. They are small, dim, cool, and extraordinarily long-lived. A red dwarf with a mass of about 1/10 the sun's mass burns its hydrogen so slowly and circulates that hydrogen through its interior so efficiently through convection that it can remain on the main sequence for trillions of years. The least massive red dwarfs may have main sequence lifetimes approaching 10 trillion years, nearly 1,000 times the current age of the universe. From the perspective of stellar evolution, red dwarfs are the last lights. They are the embers at the end of the universe's stellar era, burning so slowly and so faintly that they would barely register against the darkness of the sky if you were used to the sun's output. But they burn, and for a very long time, they will be the dominant source of starlight in a universe that has otherwise gone dark. This epoch, The era dominated by slowly fading red dwarf stars could last for trillions of years. During this time, the universe is not entirely dead. It is not yet the thermodynamic silence of full heat death. It is a dimmer, quieter, colder version of the present, with fewer and dimmer stars, wider separations between them, more complete isolation of each stellar remnant from its neighbors. But the processes of stellar physics continue. Orbits evolve. Gravitational interactions occasionally eject stars from their host systems into the dark intergalactic medium. Black holes at galactic centers continue accreting whatever matter reaches their event horizons. The universe is in a long, slow decline, but it is not yet a decline that has reached its floor. But the floor is coming. When the last red dwarf exhausts its hydrogen and expands and fades and cools into the white dwarf phase, the stellar era of the universe will be over. No more nuclear fusion occurring anywhere in the cosmos. No more stars producing light and heat through the conversion of mass into energy. The universe will have moved from the era of luminous stellar activity into what cosmologists sometimes call the degenerate era, the epoch dominated by the remnants of stars, white dwarfs cooling toward black dwarfs, neutron stars spinning down and cooling, brown dwarfs drifting in the dark between stellar remnants, and the black holes that anchor what remains of galactic structures, slowly accreting the dwindling supply of matter that falls within their gravitational reach. The degenerate era will itself last an enormously long time because the objects within it are extremely stable. A white dwarf, once it has cooled sufficiently, is held up not by thermal pressure but by electron degeneracy pressure, a quantum mechanical effect that does not require the ongoing consumption of fuel. A black dwarf, the cold final state of a white dwarf, is stable against further collapse under the conditions expected to persist for an extraordinarily long time. These objects do not burn. They do not radiate significantly. They are simply present, cold and dark and gravitationally inert in any locally meaningful sense, occupying the space they fell into when their progenitor stars died. The degenerate era may persist for timescales of 10 to the 37th years or more, depending on physical processes operating on those scales that may or may not be real, such as proton decay. If proton decay occurs, as some theoretical extensions of the Standard Model predict, at timescales of roughly 10 to the 34 to 10 to the 38 years, then even the black dwarfs and neutron stars will not survive the degenerate era intact. The protons within them will decay into lighter particles and radiation, and the structures they compose will dissolve, not through any dramatic process, not through collision or explosion or gravitational collapse, but through the slow, quantum mechanical disintegration of the atomic nuclei themselves. Matter, the familiar, tangible, solid substance of rocks and stars and bones and everything ever built or observed, will turn out not to be permanent. Given enough time, even the most stable baryonic structures will come apart at the level of their most fundamental components. What remains after proton decay has run its course, in a universe where all ordinary matter has been converted into lighter particles and radiation, and where all stellar mass objects have dissolved, is a population of black holes. The black holes, born from the collapse of massive stars and from the mergers of smaller black holes over immense periods of time, are not composed of ordinary matter in the conventional sense. Their interior is a singularity, a point where the known laws of physics break down, and where the description of matter in terms of protons and electrons loses its meaning. They survive the proton decay era, not because they are immune to thermodynamics, but because their mass energy is locked inside an event horizon from which ordinary matter-based decay processes cannot operate in the conventional sense. But as established in the theoretical framework of Hawking radiation, black holes are not permanent. They evaporate. They do so with extreme slowness, radiating energy at a rate that is inversely proportional to the square of their mass, which means that more massive black holes radiate more slowly and take longer to evaporate. A stellar mass black hole evaporates over timescales of roughly 10 to the 67th years. A supermassive black hole, of the kind that anchors a large elliptical galaxy, takes far longer, but all of them evaporate eventually, if the theoretical framework is correct. Each one radiates away its mass as thermal radiation, Hawking radiation, and as its mass decreases, the rate of radiation increases, and the final moments of evaporation, when the black hole has lost almost all of its mass, occur in a burst of emission, and then nothing. The black hole is gone. What was once a gravitational singularity with no surface and no emission has converted its entire mass into thermal radiation and dispersed into the expanding universe. After the last black hole evaporates, the universe contains no macroscopic structures. There are no stars. There are no planets. There are no galaxies, even in remnant form. There are no black holes. There is radiation, extremely dilute, extremely low energy, the product of billions of years of thermodynamic processes and stellar evolution and black hole evaporation, spread across a universe that has expanded to a scale so immense that the distances involved cannot be expressed in any unit that would have meaning to a physicist working today. There may be subatomic particles, electrons, positrons, neutrinos, photons, whatever stable fundamental particles the final state of matter dissolution produces. These drift apart in an expanding space, their separations growing with every moment, their chances of ever encountering another particle diminishing with every moment. This is heat death. This is the state toward which the universe tends. Not an explosion, not a collapse, not a transformation into something new and different, just the final exhaustion of every gradient, every concentration, every source of usable energy, and the arrival at a state of perfect thermodynamic equilibrium, where nothing more can happen, because nothing more has the energy differential required to drive it. The universe is not destroyed in heat death. It exists. It continues to exist. The fundamental particles and radiation are still there, spread across the expanding space. But they are distributed in a way that makes any further organized process essentially impossible. The entropy is at its maximum. The available work is at zero. Time continues, in the formal sense, but nothing marks it. Nothing changes that would allow a clock to tick, or a process to be distinguished from any other moment in what might be called time. There's a philosophical question that sits at the edge of this picture, one that physics itself cannot answer, and it is this. What is the difference between a universe in a state of maximum entropy, where nothing can happen, and a universe that does not exist? The matter and energy are still technically present. The geometry of space is still technically defined. But if no process can occur, if no information can be encoded or transmitted or received, if no event can be distinguished from any other event, if no observer can exist, if no measurement can be made, does the distinction between existence and non-existence carry any physical meaning? This is not a question that current physics is equipped to resolve, but the fact that it arises, that the trajectory of the universe leads to a state where it becomes genuinely unclear whether the universe's persistence is physically meaningful, is itself one of the most unsettling implications of cosmological knowledge. It gets worse, because there is a version of this story that does not even offer the mild comfort of a universe that persists in equilibrium, however meaningless that persistence might be. There are models of dark energy in which the energy density does not remain constant over time, as the cosmological constant model assumes, but increases. In these models, sometimes called phantom energy scenarios, the energy density of dark energy grows as the universe expands, rather than remaining fixed. If dark energy has this character, then the acceleration of expansion does not merely continue at its current rate. It increases. The expansion accelerates faster and faster. The scale factor of the universe grows without bound in a finite time. And in these models, the structures of the universe are not merely separated by growing distances over cosmological timescales. They are torn apart. Galaxy clusters are torn apart. Galaxies are torn apart. Solar systems are torn apart. Stars are torn apart. Planets are torn apart. Eventually, atoms are torn apart, as the rate of expansion becomes so extreme that it overwhelms even the electromagnetic and nuclear forces that hold matter together at its smallest scales. This scenario is called the Big Rip. The Big Rip is not the leading cosmological scenario. Current measurements of dark energy are consistent with the cosmological constant model, in which the energy density is fixed, and not with phantom energy. But the measurements are not yet precise enough to rule out the phantom energy possibility entirely. It remains a physical option that the observational data have not eliminated. The universe may end in the quiet equilibrium of heat death, or it may end in a tearing acceleration that unravels all structure in a finite time. Or current models may be incomplete in ways not yet understood, and the actual long-term future may diverge from both of these pictures in ways that cannot currently be anticipated. What is not in doubt is the direction, away from structure, away from accessible information, away from the conditions that make complexity and knowledge possible. There is a temptation, when confronting these scenarios, to invoke the possibility of a new beginning, to suggest that perhaps the heat death is not truly final, that quantum fluctuations in the far future might seed a new low-entropy region, a new beginning from which a new universe of structure and stars and life might emerge. This possibility has been discussed in the context of what is sometimes called a Boltzmann brain scenario, or in certain interpretations of eternal inflation. The physics involved is speculative, the timescales involved are beyond any meaningful description, and the outcome, if it occurred, would be so disconnected from any continuity with the current universe that it would be, in any practical sense, a different universe rather than a continuation of this one. It is not comfort. It is not a guarantee of renewal. It is, at most, a theoretical possibility, buried under timescales so large that the difference between them and infinity is a matter of notation rather than physical intuition. The current universe, the one containing galaxies and stars and dark matter halos, and the cosmic web and the CMB, and the record of 14 billion years of cosmic evolution, is not renewed by those speculations. It continues on its trajectory. Its trajectory leads where the physics says it leads, and the physics says it leads to separation, to fading, to cooling, to the evaporation of every large structure, to the dissolution of ordinary matter, to the exhaustion of every energy source, and to the final, complete, thermodynamic silence of a state from which nothing further can depart. You have now followed the story of the universe from the deceptive fullness of a night sky to the edge of what physics can currently say about its final condition. The journey has moved through scale, through structure, through absence, through invisible matter and invisible energy, through accelerating expansion and cosmic horizons, through stellar death and entropy, and through the long, cold, quiet future of a cosmos that began with an extraordinary concentration of order and is spending that order, irreversibly, toward an end that is not dramatic, but that is, in its completeness and its silence, perhaps more final than any explosion could be. The universe does not owe meaning to the structures within it. It does not maintain its accessible architecture for the convenience of observers who might want to read its history. It expands regardless. It cools regardless. It dissolves its structures regardless of whether anything within them is watching. The cosmic web, for all its intricate filamentary beauty, for all the billions of years it took gravity to assemble from the quantum fluctuations of the early universe, is not a monument. It is a phase, a temporary arrangement of matter and dark matter and gas and light that exists within a window of cosmic time and that will be erased, not by catastrophe, but by the patient operation of physics proceeding in its only permitted direction, and the voids will remain. Long after the filaments have thinned and the clusters have merged and the stars have faded and the black holes have evaporated, what will characterize the universe more than anything else is still emptiness. The expanding, cooling, increasingly featureless emptiness of a space that once contained everything, and that will, in the end, contain almost nothing that can be distinguished from the rest. The voids will not have won exactly, because there is no contest, but they will have become the universal condition. The temporary concentrations of matter that briefly interrupted them, that gave them their contrast and their definition, will be gone, and what remains will be what the void always was: space, expanding with almost nothing in it, in all directions, forever. There is a final thing to say about what it means to know this, not to speculate about it, not to imagine it from a comfortable distance, but to genuinely absorb the knowledge that this is the direction of the universe that produced you, that the same physics that assembled the atoms in your body from stellar nucleosynthesis across multiple generations of stars is the physics that will, on timescales so vast they cannot be felt, dissolve every structure that exists, including the record of every structure that ever existed, into a state of perfect, meaningless equilibrium, that the cosmos did not arrange itself so that its history would be preserved, or its complexity would persist, or its most intricate constructions would endure. It arranged itself, as far as physics can determine, in such a way that none of those things are guaranteed and all of them are temporary. This is not pessimism. It is not a conclusion anyone chose or wished for. It is what careful observation, combined with mathematical theory developed over the course of more than a century of modern physics, produces when followed without flinching. The universe has a direction. That direction is known well enough that the broad shape of the destination can be described, and the description does not include, on any timescale that current physics can access, a stable, luminous, interconnected cosmos where knowledge accumulates and meaning compounds over cosmic time. It includes instead the slow replacement of that cosmos by something that barely qualifies as a state at all, a nearly uniform, nearly featureless, nearly incomprehensibly cold and empty condition that will persist for longer than any number with a name can describe. The night sky above you, the one that started all of this, is still there. The stars are still burning. The galaxies are still grouped into their clusters and threaded along their filaments. The cosmic web is still visible to instruments capable of seeing it. The CMB is still filling space in every direction with its faint thermal whisper, and from the surface of this small, warm, populated planet, it is still possible to look up and feel surrounded by something immense and structured and ancient and, in its own physical way, extraordinary. That feeling is not wrong. It has never been wrong. It is simply incomplete, because the universe that produces that feeling is not the universe in its final form. It is the universe in its brief, luminous, structured, accessible middle passage, the era when matter had organized itself into something intricate, when light still traveled between galaxies before the expansion carried them beyond reach, when an observer standing on a planet could look outward and see the record of everything, when the entropy had been spent enough to build complexity but not yet enough to dissolve it. That window is not permanent. Its boundaries are defined by physics, not by human preference, and within it, the most honest response to the cosmos may not be wonder alone or fear alone, but the particular quiet weight of knowing that what you are seeing is irreplaceable, a view that will not exist again, of a universe arranged in a way it will not be arranged again, carrying an accessible history that will not be accessible again. The weight of that knowledge does not distribute itself evenly. It settles in different places depending on how long you allow it to remain. For most of human history, the cosmos was experienced as a ceiling rather than a depth, something above, something fixed, something that defined the boundary between the human world and whatever lay beyond it. The stars were markers, not distances. The sky was a surface, not a volume. And within that framework, the question of what the universe ultimately is, what it is made of, where it is going, what it will become, did not arise in its current form, because the cosmos was understood as a permanent backdrop rather than a physical system with a trajectory. The transition from ceiling to depth happened slowly, over centuries, through the accumulation of observations that kept revealing more distance behind what had seemed like the final boundary. Every instrument that looked further found more. Every model that accounted for what was seen required something larger to contain it. The stars became suns. The cloudy patches between them became galaxies. The galaxies became constituents of clusters. The clusters became nodes in a web. The web became the visible surface of something mostly invisible. The expansion of the universe from a compressed early state became the organizing framework for everything else. And with each step deeper into the actual scale of the cosmos, the human position within it became simultaneously more specific and more marginal, more precisely located and less cosmically significant in any absolute sense. This is not a conclusion that physics forces you to accept as a value judgment. Physics does not assign significance. It describes structure, behavior, and trajectory. But the structure it describes, the behavior it identifies, and the trajectory it calculates all point toward a cosmos in which the conditions currently permitting complex, organized, information-rich structures are temporary, in which the accessible portion of reality shrinks over time rather than expanding, and in which the final state of the universe bears almost no resemblance to its present state, except in the most formal mathematical sense. Whether that has implications for significance is a question that belongs to philosophy rather than physics, but it is a question that physics has made newly urgent by providing, for the first time in human intellectual history, a reasonably detailed account of the universe's likely destination. What physics has given us is not merely a set of facts about distant objects in large numbers. It has given us a temporal perspective, a way of situating the present moment within a timeline that extends backward to the beginning of the observable universe and forward to the endpoint that thermodynamics and expansion jointly define. And within that timeline, the present moment, this specific era of cosmic history, occupies a position that is neither the beginning, nor the middle, nor anything close to the end in terms of elapsed time, but that is, in terms of the richness and accessibility of the cosmos, closer to a peak than to anything that will follow. The era of luminous, structured, interconnected, observable cosmic complexity may be, if the physics is correct, the best the universe has to offer. Not the latest version, not a step towards something more elaborate, but an era that will be followed by simplification, by separation, by fading, by the slow but irreversible movement toward a state where complexity of this kind is no longer physically sustainable. Consider the specific improbability of the current cosmic arrangement. Not improbability in the sense that it required supernatural intervention, but improbability in the purely physical sense, the conditions that currently allow observers to exist within the universe, to look outward and see the full scope of its structure, to detect the CMB, to measure the acceleration of expansion, to map the cosmic web, to discover dark matter and dark energy, to understand the trajectory of the universe's future. Those conditions are not generic. They are not typical of the universe's long history or its longer future. They are specific to a narrow window of cosmic time, defined on one side by the universe being too hot and dense for complex structures to form, and on the other side by the universe being too cold, too dark, too isolated, and too informationally impoverished for such understanding to be assembled. The window is open now. The CMB is still detectable. The distant galaxies are still within the cosmic event horizon. The cosmic web is still visible in surveys. The evidence for the Big Bang is still present in the observable universe. The physics required to deduce the universe's history and trajectory is still accessible. All of this will not always be the case. The window has limits. Its far edge, defined by the progressive retreat of evidence beyond the cosmic horizon and the progressive extinction of stellar energy sources, is approaching on timescales that are long relative to human civilization, but that are, in the full context of the universe's expected future duration, extraordinarily near. This is the thought that the void has been building toward from the beginning. Not the void as a metaphor for despair or meaninglessness, but the void as a physical fact, as the dominant spatial condition of the universe, as the template toward which the cosmos moves, as the region that defines by its scale and its persistence and its expansion what the universe mostly is and increasingly will be. The void is not the absence of the universe. The void is the universe's default state. The filaments and clusters and stars and galaxies are the exception. They are what happens when the physical conditions are sufficiently specific, when density fluctuations in the early universe happen to fall within the right ranges, when dark matter halos form with the right masses, when gas cools and collapses, when nuclear reactions ignite and maintain themselves, when gravity and thermal pressure find a temporary balance. All of those conditions are temporary. All of those conditions eventually fail. And when they fail, what remains is what was always there beneath them. The void, expanded, cold, empty, and patient. The patience of the void is not a literary device. It is a physical fact. The void does not act. It does not work toward anything. It does not have a purpose or a preference. But the physics that governs the universe consistently moves in the direction of the void's characteristics: lower density, lower temperature, less structure, less energy available for organized processes. The void is not waiting for the luminous universe to end. The luminous universe is spending itself toward the void's condition by the operation of its own physics, irreversibly and without exception. Every star that burns is a step. Every photon that disperses into the expanding space is a step. Every galaxy that crosses the cosmic event horizon and disappears from any observer's reach is a step. The steps are all in the same direction, but it goes deeper, because the void in the end is not merely a physical condition, it is an epistemic one. The universe's long-term trajectory does not merely produce a physical emptiness, it produces an informational emptiness. It erases the record, it removes the evidence, it places the history of the cosmos beyond any boundary that any future observer could cross. And in doing so, it does not merely create a cold and dark physical environment. It creates a universe in which the knowledge of the universe itself becomes impossible. A place where the question of what the universe is cannot be answered, not because the instruments are insufficient, but because the information required to answer it has been geometrically quarantined by expansion into regions of space that are causally disconnected from any observer forever. This is the deepest consequence of accelerating expansion, and it is one that sits at the intersection of physics and epistemology in a way that is genuinely uncomfortable to hold in mind. The universe is not merely becoming empty, it is becoming unknowable. Not to current observers, not yet, not for an extraordinarily long time. But the trajectory is established, the horizon is moving, the evidence is receding, and the laws of physics, as currently understood, provide no mechanism by which this process reverses or by which the lost information becomes recoverable. What is beyond the cosmic event horizon is beyond it permanently. What crosses it never returns, and more is crossing it with every passing year, every passing century, every passing million years, at a rate that dark energy will continue to accelerate. There is a silence that comes after understanding this that is different from the silence before. It is not the comfortable silence of ignorance, the silence of a person who looks up at a clear sky and sees beauty without asking where the beauty leads. It is the silence of having followed the question to its end and found that the end is not a wall, but an absence, not a boundary you can press against and feel the solidity of, but an expanding region of inaccessibility that moves away from you faster than you can approach it, and that contains beyond its continuously retreating edge all the information that would be required to know the full extent of what has existed. You cannot stand at the edge of the observable universe and look across it into what lies beyond, not because no one has built the instrument, because the light from what lies beyond has not reached you, and in most cases will never reach you, because the expansion of space between here and there is outrunning the light's journey. The edge of the observable universe is not a place. It is a temporal boundary. The distance that light, traveling since the earliest moments of cosmic history, has managed to cover in the time the universe has existed. Beyond that boundary, the universe continues. It contains matter and structure and presumably voids and filaments and clusters similar to those within our observable sphere, but we cannot see it. We cannot detect it. We cannot receive any signal from it. And as expansion continues, the volume of the universe that we can ever access, ever receive information from, ever include in any observation or experiment or theoretical inference, is not growing. It is shrinking. The observable universe is not expanding. It is contracting in terms of what the future will be able to observe. This asymmetry between the physical expansion of space and the contraction of accessible cosmic volume for any observer is one of the cruelest geometric facts in cosmology. The universe gets larger, but the observable universe, the region from which signals can reach any given point, gets smaller, larger in physical extent, smaller in informational reach, more spacious and less knowable simultaneously. Growing in the dimension of volume, shrinking in the dimension of contact, the universe expands into isolation, and the isolation is mutual and complete and permanent. Follow this to the specific scale of a galaxy or a galaxy group, a gravitationally bound structure in the far future, after the cosmic web has thinned to incoherence and the external galaxies have all retreated beyond the horizon, is an isolated island in an expanding ocean with no shores. It cannot reach anything outside itself. Nothing outside it can reach it. Its internal physics continues. The stars within it burn and die and leave remnants. The black hole at its center accretes whatever falls within its gravitational reach. The entropy of its internal systems increases in the normal direction, but it is informationally sealed from the rest of the universe. Whatever happens inside it is known only inside it. Whatever has happened outside it, including the entire history of the cosmic web and the 2 trillion galaxies that once populated the observable universe, is inaccessible, not in principle, but in the absolute physical sense, defined by the geometry of an expanding spacetime. And this matters not simply as an abstract cosmological fact, but as a statement about the relationship between existence and knowledge. For any observer within that isolated island, the universe is not merely smaller than it is for us today. It is a fundamentally different kind of place, a place where the scope of what can be known is bounded not by the limitations of current technology or the incompleteness of current theory, but by the laws of physics operating on the geometry of space. Their universe has a hard wall around its accessible content, and that wall is not a frontier in the exploratory sense. It is a horizon in the absolute sense, a boundary defined by the finite speed of light and the infinite patience of expansion, and it admits no exceptions and no circumvention. What would it mean for a civilization in such a universe to do science? To try to understand the cosmos, they would observe what they could. They would measure the stars of their island, map the dynamics of their merged galaxy, study the physics of their local environment with whatever sophistication their development allowed, and they would, almost certainly, construct a cosmological model, a picture of the universe based on the evidence available to them, and that picture would be accurate in the sense that it would be consistent with all their observations, and it would be wrong in the sense that it would describe a universe of one galaxy in an infinite dark expanse when the actual universe is, or once was, something incomparably more complex and populated and structured than their observations could ever reveal. They would not know they were wrong. Their instruments would not fail them. Their mathematics would not betray them. Their observations would be real, and their inferences would be valid. They would simply be working with a data set from which the most important information had been physically removed by the expansion of the universe before their civilization came to exist. Their cosmology would be a cosmology of the remnant, of the island, of the accessible portion. And the accessible portion would tell them almost nothing about the whole. This is not a hypothetical in the science fiction sense. It is a physical prediction with a timeline that, while far beyond any human planning horizon, is not in any meaningful sense uncertain in its direction. The universe is constructing this future, It is building it with the same patient, law-governed, impersonal physical processes that built the cosmic web and ignited the first stars and shaped the voids. It is building it by expanding, by accelerating that expansion, by carrying information beyond the reach of any observer, by cooling every energy source toward uselessness, by dissolving every structure that was not already dissolved, and by arriving at a state where the question of whether the universe can be known from within is answered, finally and permanently, in the negative. The specific cruelty of this, if cruelty is a word one can apply to physical law, is not that the universe ends. It is that the universe persists but becomes unknowable. It continues to exist in some formal physical sense long after it has become incapable of containing any process that could constitute knowledge or experience or meaning. It does not spare observers by ending. It removes the conditions for observation while maintaining the conditions for mere geometric persistence. The lights go out not all at once but one by one, over timescales so immense that each individual extinction is cosmically insignificant, until the cumulative effect is a universe in which nothing shines, nothing connects, nothing can be measured or detected or understood from any internal vantage, and yet which technically still exists in the cold arithmetic sense of occupying space and containing the dispersed remnants of what was once the entire luminous cosmos. This is the ending that the physics suggests, not fire, not collapse, not the violent drama that the human imagination, calibrated for events on human timescales and human scales, tends to reach for when imagining the end of things. The ending suggested by the combination of accelerating expansion, thermodynamic law, stellar evolution, and the behavior of matter on the longest timescales is quiet to a degree that the word quiet cannot adequately contain. It is the quietness of a place where sound cannot exist because there is no medium, and no source and no receiver. The quietness of a temperature so close to absolute zero that the distinction between motion and stillness becomes a matter of quantum uncertainty rather than observable dynamics. The quietness of a space so vast and so uniform and so featureless that no variation within it could be detected by any instrument that any observer could construct, because no observer exists, and no instrument could be assembled from the dispersed and inert particles that constitute the universe's final inventory. You began this journey looking up. You began with the night sky and the feeling that the universe was full, was close, was populated with the kind of richness that 5,000 visible stars and a faint galactic smear and the knowledge of 2 trillion galaxies beyond them seems to promise, and nothing about that starting point was false. The stars are there, the galaxies are real. The cosmic web is a genuine structure, assembled over billions of years through real physics operating on real matter, and it is, by any aesthetic measure that a human being can bring to it, extraordinary. The voids that define it by contrast are real. The dark matter that scaffolds it is real, even if its nature remains unknown. The dark energy that is separating its components is real, even if its origin remains uncharacterized. The CMB is real, the expansion is real, the acceleration is real, the trajectory is real, and the trajectory leads here, to this final picture. A universe that began with an extraordinary concentration of order, that spent billions of years converting that order into structure and complexity and light, that produced in the course of that spending the conditions for stars and planets and chemistry and biology, and the specific kind of nervous system capable of looking upward and feeling surrounded by something immense, and that is now, in the era of that same upward looking, already past its peak of accessible richness and moving, one exhausted gradient at a time, toward the condition the voids have always represented, an absence so complete and so vast and so permanent that no boundary separates it from the void of genuine non-existence except the cold arithmetic of conservation laws, and the formal presence of dispersed particles too separated and too inert to ever interact meaningfully again. The universe will not end with a sound. It will not end with light. It will not end in a way that any observer within it could witness, because the observers will have long since become physically impossible before the final thermodynamic silence is reached. The ending is not an event. It is a state, a condition arrived at through the accumulation of innumerable small steps, each one unremarkable, each one physically necessary, each one contributing its small increment to the total entropy of a cosmos that has been moving toward this condition since the first moment of its existence. And it is this, more than any single fact about dark matter or dark energy or the size of the largest voids or the timescale of black hole evaporation, that constitutes the deepest implication of what cosmology has spent a century carefully, rigorously, and honestly discovering. The universe is not arranged for permanence. It is not structured for the persistence of complexity, or the preservation of accessible history, or the maintenance of conditions suitable for knowledge. It is a physical system governed by physical laws, and those laws, followed without exception and without sentiment across the full span of cosmic time, produce a future that is not merely different from the present, but categorically and irreversibly less structured, less luminous, less connected, less knowable, less in the end, in every dimension that a mind shaped by the present universe would use to measure what the universe has to offer. The night sky is still there. The stars are still burning. The voids are still expanding. The cosmic web is still threaded between them. The CMB is still whispering in every direction, carrying the encoded memory of the universe's earliest moments. Dark matter is still holding the filaments together. Dark energy is still widening the distances. Entropy is still running in its only permitted direction. And somewhere in the cold interior of the largest voids, in the featureless dark between the filaments in the expanding space that separates every gravitational island from every other, the future is already present, not waiting, not approaching, already here in the physics, in the direction, in the trajectory that was established before the first star ignited and that will continue long after the last one cools to dark. What you are looking at, when you look up at a clear night sky and feel surrounded by the cosmos, is the luminous surface of something that is almost entirely absence. You are seeing the exception. You are living inside the exception. And the exception, by every measure that the physics of this universe provides, is not permanent. It is brief. It is already fading. It is, from the perspective of the full temporal scope of the universe, barely distinguishable from the moment it began. And what surrounds it, what preceded it in a different form, what will outlast it by an incomprehensible margin, is the void, patient, expanding, cold, dark, and indifferent, the universe's truest face, the condition to which all things tend, the silence into which all light eventually falls and from which nothing, on any timescale that physics can currently describe, returns. There is something that happens in the mind when it genuinely absorbs scale, not when it reads a number and nods at its size, not when it performs the arithmetic and confirms that the result is large, but when it actually holds the proportions without flinching, when it allows the relationship between what is familiar and what the numbers describe to be felt rather than merely acknowledged. What happens is not wonder, exactly. Wonder is what occurs at the threshold, when the scale is first encountered, and the mind registers its own inadequacy to contain it. What happens after wonder, if you remain with the scale long enough, is something quieter and less comfortable, a kind of recalibration, a shift in the perceived position of the self, relative to everything else, not a diminishment in the emotional sense, but a correction, the way a map corrects a false impression of distance when you finally see it drawn accurately. The correction the universe offers is this: you are a temporary concentration of matter in a universe that is almost entirely empty, that is becoming more empty with every moment that passes, and that will eventually be so empty that the concept of concentration will have no physical instantiation anywhere within it. You are made of atoms forged in stars that no longer exist, assembled by processes that required billions of years of prior cosmic evolution to produce the conditions for chemistry, then biology, then the specific neural architecture capable of generating the experience of looking upward and asking what is there. You are, in the most literal physical sense, the universe briefly organized into a form capable of examining itself. And the universe, as it examines itself through you, finds that it is structured in such a way that self-examination is a cosmically rare and temporally narrow phenomenon, possible only during a specific window of the universe's history, and not guaranteed to leave any permanent trace. That last part is the part that does not soften with familiarity. The examination leaves no permanent trace. The knowledge assembled, the models constructed, the observations recorded, the entire accumulated edifice of human understanding of the cosmos that has been built over the course of centuries of careful, rigorous, disciplined inquiry, is not written into the fabric of the universe in any way that persists beyond the physical medium on which it is encoded. It is encoded in matter, in books, in electronic storage, in the neural configurations of living brains. That matter is subject to the same physical laws as all other matter. It will not persist indefinitely. It will dissolve, as all matter dissolves, on the timescales that the physics of this universe defines, and when it dissolves, the knowledge dissolves with it, not into some other form where it is preserved, into the thermal noise of a universe in which no structure capable of encoding or decoding information remains. This is not a reason to not acquire or value knowledge. It is not a reason for anything, because physical facts do not generate normative conclusions by themselves, but it is a fact that sits in a specific relationship to every other fact that knowledge has produced. Every discovery, every measurement, every model, every insight that has ever been generated about the nature of the cosmos has been generated within a system that is moving, consistently and irreversibly, toward a state in which that generation is impossible. The acts of knowing are occurring within a window that the physics of the universe defines, and the physics of the universe is closing. The window is wide. It will remain open for an extraordinarily long time by any human measure, but it is not permanent, and the universe contains no mechanism for reopening it once it is closed. Think about what has actually been accomplished within this window. A species of primate on a rocky planet orbiting an unremarkable star in the outer region of a spiral arm of a galaxy that is one of 2 trillion similar structures in the observable universe has, within the last few centuries, determined the age of the universe to within a fraction of a percent, has measured the geometry of space on the largest accessible scales, has discovered that the majority of matter is invisible and unidentified, has discovered that the majority of the universe's energy content is an unknown quantity associated with empty space, has reconstructed the history of cosmic structure formation from the first fractions of a second after the beginning to the present large-scale architecture, has calculated the future trajectory of the universe to the point of thermodynamic heat death, has identified the precise mechanism by which its own existence became physically possible, stellar nucleosynthesis across multiple generations of stars, producing the carbon and oxygen and nitrogen and all the heavier elements that biochemistry requires, has discovered that the window in which this kind of knowledge is possible is finite, and that the universe is not structured to preserve the knowledge beyond the window's close. The appropriateness of that last discovery, the fact that the most sophisticated product of cosmic evolution, discovered through its own inquiry, that the conditions for its inquiry are temporary, has a quality to it that is difficult to characterize without reaching for language that physics does not use. It is not ironic in the literary sense. It is not tragic in the dramatic sense. It is simply the structure of the situation, a self-examining process that discovers through its examination the conditions of its own finitude, not as a philosophical abstraction, as a physical measurement, as a consequence of equations that have been tested against observations and found to describe reality with extraordinary accuracy. The equations do not care. This needs to be said plainly, because there is always a temptation to attribute to the universe a quality of response to the minds it has produced, as if the cosmos registers, in some way, the fact that it is being observed and understood. It does not. The universe is not indifferent in the sense of having considered caring and rejected it. It is indifferent in the more complete sense of not being the kind of thing that has responses. It is a physical system governed by physical law. It does not register the presence of observers. It does not modify its trajectory in response to what those observers discover about it. It does not offer consolation. It does not offer significance. It offers only what it is, an enormously old, enormously large, predominantly empty, thermodynamically declining physical system that happens, in the present era, to contain within a small fraction of its accessible volume the specific conditions required for matter to organize itself into forms complex enough to ask what it is, and what it is, at the level of its full physical description, is mostly void. The cosmic web, for all its structural intricacy, occupies a fraction of the universe's volume. The matter it contains, ordinary and dark combined, constitutes a fraction of the universe's total energy content. The luminous matter, the stars and gas that can actually be seen, constitutes a small fraction of the matter. The planets, the rocky bodies that provide surfaces on which chemistry can persist, constitute a small fraction of the luminous matter. The inhabited planets, if this one is not unique, constitute a small fraction of the planets, and the specific interval of each inhabited planet's history during which its inhabitants can look outward and understand the full scope of the universe they inhabit is a small fraction of that planet's existence. Small fractions of small fractions of small fractions, embedded in the corner of a structure that is itself embedded in the temporary luminous portion of a universe that is almost entirely empty and becoming more so. The voids are not the backdrop, they are the content. When you calculate the total volume of the observable universe and ask what fills it, the answer is not galaxies. It is not dark matter halos. It is not gas or radiation or the cosmic web in any of its components. The answer is void, empty, expanding thermodynamically extreme void, at temperatures close to absolute zero, at densities far below anything achievable in any laboratory, across distances that dwarf the luminous structures at the Webb's nodes by factors of hundreds of millions. The void is not where the universe is not. The void is where the universe mostly is. Everything else, the stars, the galaxies, the Webb, the light, the life, is the local and temporary exception to a spatial condition that defines the vast majority of what exists. This is the view from outside the exception. This is what the physical description of the universe looks like when you do not privilege the perspective of an observer embedded in a galaxy, surrounded by a stellar neighborhood, illuminated by a nearby star, looking outward and seeing, understandably and forgivably, a sky that appears full. The sky is not full. It is almost entirely empty. The points of light in it are separated by distances so vast that the light traveling between them takes years to centuries to millions of years to cross. The galaxies in the deeper sky are separated by distances measured in millions and billions of light years. And between all of those structures in all of the space that is not occupied by a star or a gas cloud or a galaxy or a filament, there is void, cold, dark, expanding, patient void. The same void that will outlast every structure in the universe. The same void that the universe is moving toward, with every process that any structure within it undergoes. There is no resolution to this that physics provides. There is no discovery waiting to be made that will change the trajectory. The cosmological constant, or whatever dark energy turns out to be at the level of fundamental physics, is not a mistake in the equations. It is what the universe is doing. The second law of thermodynamics is not an approximation that breaks down at extreme scales. It is the direction of time. Stellar evolution does not reverse. Black holes do not disgorge the matter they have absorbed in a form that can reconstitute the structures it came from. The cosmic event horizon does not move inward, restoring access to galaxies that have receded beyond it. None of these things have exceptions. None of them have alternatives hidden in unexplored physical territory. The unexplored physical territory may contain many surprises. It will not contain a mechanism by which the universe changes direction. The direction is set. It was set, arguably, from the moment that the conditions of the early universe determined the balance between matter, dark energy, and the geometry of space. Those initial conditions, whatever produced them, whatever preceded them, whatever the phrase preceding the beginning of the observable universe even means, produced a universe with a specific ratio of components and a specific geometry and a specific set of physical laws, and those laws, applied to those initial conditions, generate a trajectory with a definite endpoint. The endpoint is not in doubt in its broad character. The specific timescales, the specific physical mechanisms operating on the longest timescales, the question of proton decay, the ultimate behavior of dark energy, the quantum gravitational effects near the final stages of black hole evaporation, these involve genuine uncertainties, but the direction is not one of them. Follow the direction far enough, and you arrive at a place that has no features distinguishable from pure absence, except in the most formal physical accounting of the particles and radiation dispersed through it. A place where the word universe refers to something that barely merits the name, not because it fails to satisfy some formal definition, but because the definition refers to conditions so far from anything that the word universe currently evokes, that the continuity of terminology conceals a radical discontinuity of character. The universe of heat death and the universe of tonight's clear sky are the same physical system at different points in its trajectory. They share conservation laws and the same fundamental particles and the same four forces. They share nothing else that would make them recognizable as versions of the same place. Tonight's sky has warmth in it, if warmth is a property that can be assigned to something at such distances, not thermal warmth. The warmth of the fact that the light reaching your eyes has traveled across years and centuries and millennia, from sources that were burning with nuclear fire, sources that were converting mass into energy through the same fusion reactions that the universe used to assemble every atom in your body, from the simpler atoms that preceded them. There is a physical connection between the light arriving at your retina and the stellar nucleosynthesis that produced the carbon in your cells. You are made of what the universe made before you. You are watching the universe make more of the same, while it still can, while the conditions for that making persist. Before the exhaustion of the fuel reserves and the cooling of the remnants and the expansion of the voids and the darkening of the sky, convert the making into the unmade. The connection is real. It is not metaphorical. The carbon in your body was forged in a stellar core that no longer exists, in a nuclear reaction that occurred billions of years before the solar system formed, and that material was expelled into the interstellar medium by the star's death and incorporated into the molecular cloud from which the solar system condensed, and it has been part of the solar system since its formation 4.5 billion years ago, and it has been part of living chemistry on this planet for as long as this planet has harbored living chemistry, and it is part of you now, arranged into the specific molecular configuration that constitutes a nervous system capable of contemplating the origin of its own atoms. The path from the stellar core to the contemplating mind is not a metaphor for connection. It is a physical chain of cause and consequence, without a break. And the endpoint of that chain, the contemplating mind looking upward at the night sky, has used its contemplation to discover that the chain does not continue indefinitely, that the conditions allowing the chain to exist, to be forged and expelled and condensed and assembled and complexified into the specific arrangement of matter capable of tracing the chain backward to its source. Those conditions are temporary. The universe that produced the contemplation cannot sustain the contemplation forever. It cannot even sustain the conditions for contemplation for anything more than an infinitesimal fraction of its total expected duration. What it has produced, it is in the process of dissolving. Not quickly, not cruelly, just steadily, by physics, without exception, without recourse. This is the thing the void has always known, in the sense that a physical condition can be said to know the truth it embodies. The void has no knowledge, it has no awareness, it has no perspective from which it registers its own dominance or the transience of the luminous structures at its margins, but it has persistence, it has scale, it has the thermodynamic sanction of a universe moving in its direction, and in the absence of any opposing force capable of reversing that movement, the void's persistence is what physics calls the future. The filaments will thin, the galaxies at their intersections will drift apart or merge into isolated remnants. The stars within those remnants will burn through their fuel and cool into darkness. The remnants themselves will dissolve, either through proton decay or through the evaporation of whatever black holes they harbor, on timescales so immense that the universe's current age is not a meaningful fraction of them. And when the dissolving is complete, when the last particle has decayed and the last black hole has evaporated, and the last photon has redshifted to a wavelength longer than the accessible universe, the void will not have won. It will simply have become everything, which is what it was always going to become, which is what the physics of this universe pointed toward from the moment its initial conditions were set. You look up at the night sky, and you see light. You see the exception. You see the universe in the only way it is possible to see it from inside it, from within a gravitationally bound structure, surrounded by the products of stellar nucleosynthesis, illuminated by a nearby fusion reactor that has been burning for 4.5 billion years and will continue for roughly another 5 billion. From this vantage, the universe looks inhabited, populated, full of energy and process and structure. From this vantage, it is easy to assume that what you see is representative, that the cosmos at large resembles the local cosmic neighborhood, that the stars and galaxies extend outward in something like the density visible from here, that the universe is, at its core, a luminous and structured place. It is not. It is a void with inclusions. It is an emptiness in which a small fraction of the available matter has temporarily organized itself into luminous structures, and those structures are embedded in the void the way rare knots are embedded in an otherwise smooth and featureless fabric, locally dense, globally negligible, surrounded on all sides by the fabric's dominant character. And the fabric is expanding. The knots are not tightening as it expands. They are becoming more isolated within it, more separated from each other, more perfectly alone in the volume they occupy, while the fabric grows and the void grows with it, and the exceptions that the knots represent become increasingly exceptional with every passing cosmic second. This is the universe, not the universe as it appears from one small planet on one clear night. The universe as the physics describes it when followed without comfort, without the instinctive softening that the mind applies to conclusions it finds difficult to sustain. A predominantly empty, acceleratingly expanding, thermodynamically declining physical system that produced, in the course of its evolution, the conditions for matter to organize itself into forms complex enough to understand what the universe is. And what the universe is, understood completely and honestly, is a place that will not sustain those forms forever. A place that is, in the full arc of its trajectory, indifferent to the fact that it briefly sustained them at all. The stars do not know they are burning. The void does not know it is expanding. The cosmic web does not know it is dissolving. The universe does not know it is being observed. And the observer, looking up at the sky on a clear night, knows all of these things, knows them through the accumulated effort of centuries of inquiry, knows them with the precision of instruments and the rigor of mathematics, and knows also that the knowing is contained within a physical system that is moving away from the conditions that make knowing possible, and that is not, as far as physics can determine, moving back. The sky above you is the universe making its light available for one more night, not deliberately, not as an offering, as a physical consequence of the fact that stars in a particular evolutionary stage emit photons at particular wavelengths, and some of those photons happen to travel in the direction of this planet, and some of those photons happen to reach the surface, and some of them happen to enter an instrument, biological or otherwise, capable of registering them. That is all it is. And it is enough to see by, for now, while the stars last, while the sky is still lit, while the window remains open and the evidence is still present, and the universe has not yet fully become what the physics says it will become. Step outside tonight if the sky is clear. Look up for longer than you usually do. Let the scale settle rather than retreating from it. Let the distance of each point of light register as an actual distance, rather than a decorative feature of a familiar ceiling. Let the voids between the visible stars be what they are, the dominant spatial character of a universe in which those stars are local and temporary anomalies, bright moments in a dark and expanding place that was dark before them and will be dark long after them. Let the knowledge of what lies beyond the visible stars, the galaxies, the clusters, the filaments, the voids, hundreds of millions of light years across, settle into the scale where it belongs, rather than remaining an abstraction too large to feel. And then consider that what you are looking at has a direction, that the light entering your eyes is a message from a universe that is not waiting for you, not arranged for you, not structured in a way that preserves what it has built, that the cosmic web visible in the deepest surveys is already being unbuilt by the same expansion that built it, that the evidence for the universe's own history is being carried beyond reach by the same physics that produced the history, that the conditions making this moment of understanding possible are specific to an era that the universe is passing through rather than arriving at, that the night sky you are looking at is, in the full temporal context of the universe's existence, a brief illumination in an otherwise dark and empty room. The room was dark before the stars ignited. It will be dark again after the last one cools, and the darkness that will follow is not the darkness of potential, the darkness of a room waiting to be lit. It is the darkness of completion, the darkness of a process that has run its course and arrived at its endpoint and has nothing further to spend. The entropy will be at its maximum. The available work will be zero. The temperature will be as close to absolute zero as a universe still technically containing dispersed particles can achieve. The expansion will continue, because nothing stops it, carrying those particles further apart with every moment in a space that has no edge and no center, and no feature by which any moment can be distinguished from any other. There will be no observer to register any of this. The physics does not require an observer to proceed. It has never required one. The universe expanded before anything existed to detect the expansion. It formed the first stars before anything existed to see them ignite. It assembled the cosmic web before anything existed to map it. It will dissolve every structure it has built before anything capable of witnessing the dissolution is left to witness it. The observer is a late and temporary feature of a universe that was very old before observers became physically possible, and that will be incomprehensibly older after they have ceased to be physically possible. The universe does not have a perspective. The perspective belongs to the observer, and the observer is not a permanent feature of the universe, which means that this, specifically this, the act of looking up and knowing what you are looking at, of holding in a single mind the 14 billion year history of a universe that began in a hot, dense state and expanded and cooled and differentiated into the cosmic web and produced stars and planets and chemistry and biology and nervous systems and instruments and theories and the specific understanding that all of it is temporary and moving in a single thermodynamic direction. This act is not a feature of the universe. It is a feature of the window. It belongs to the era. It is possible now. It will not always be possible. And the universe will not notice when it is no longer possible, because the universe does not notice anything, has never noticed anything. And the fact that it briefly contained things capable of noticing was a physical accident of the most magnificent and unrepeatable kind. The void is patient because patience is not a property it possesses but a description of what it is, a physical condition that requires nothing to sustain it, that is not working toward anything, that does not diminish through waiting, because waiting is not what it does. It simply is. It simply persists. It simply expands, cooling as it expands, emptying as it expands, becoming more completely what it has always been with every unit of time that passes, indifferent to the units, indifferent to the passing, indifferent to the existence or non-existence of anything capable of marking the passage. You are made of the universe looking at itself. You are the universe's brief, local, improbable capacity for self-examination, assembled from stellar remnants, and sustained by a nearby star's output, and embedded in a gravitational structure that is itself embedded in the cosmic web that the universe spent billions of years constructing, and is now in the process of gradually abandoning to expansion and entropy. You contain, in the pattern of your neural connections, the most accurate picture of the universe that the universe has yet produced of itself. And that picture shows a universe that will not always produce such pictures. A universe that is, in the only direction it moves, moving away from the conditions that made the picture possible. This is not a reason to look away. It is a reason to look more carefully, while the looking is still possible, while the light is still arriving, while the window is still open, while the universe still has enough structure left to be worth the looking. The void at the edge of every filament, the void that occupies the majority of the observable universe's volume, the void that will eventually become the universal condition, is already vast enough to be felt in the intervals between the stars. It is already present in the darkness that surrounds every point of light in the sky above you. It is not coming. It is already here, in the space between things, growing at the edges of everything, patient in the way that only something indifferent to time can be patient. The stars will burn tonight, they burned last night, they will burn tomorrow night, and for a very long time after that, by any human measure, the sky will continue to be lit, and the universe will continue to be observable, and the window will continue to be open. But the universe does not make promises, and the physics does not make exceptions, and the direction is not subject to revision. The void is not a metaphor for what we fear. It is a description of what is actually there. And what is actually there, surrounding every structure in the observable universe, filling the majority of space in every direction to the limits of what can be detected, cooling and expanding and patient and vast, is the universe's dominant truth. It is the thing the cosmos mostly is. It is where everything tends. It is where everything goes. And it was never, at any point in the 14 billion years of this universe's existence, waiting for anything to arrive.